Yeah, it's true. I mean, I was like looking back at my other videos, and every video I have the same shirt and I have the same like a couple copy changes, and it's always like, here we go again. And yeah, I won't even deny it. I'm wearing the same pajamas I was wearing last time I did this thing. Like I woke up, just like an hour ago, talking to my wife. She's going off to do her artwork. She's just exploding. She's got so much to do, and we're going on a trip in 2 weeks. So I kind of want to get this stuff done. But with this entire like stuff that we've been doing, it really feels a lot like I'm cramming, just like really cramming for a test or something. But I'm making sure that I get it right. It has that same feel. It's like, oh, I can push through and we can figure this out. But then I have a feeling it's like, if you're just going to push through and learn all of Kubernetes, you're going to be pushing through for like a year and a half. So the topic today is certifications, not educational training certifications, but X509 certs, which is the basis of, I think PKI stands for public key infrastructure, right? Did I get that right? PKI, public key infrastructure. I got it. Yay. One answer for me. 10 points. Production cases, no joke. All these resources are basic. They're all for things that have cloud. They're not, the things that are out there are not for the stuff that we're doing by every consideration. I've had people who are, on the board, and I've had people inside. The stuff that we are doing is considered advanced. And I'm like, really? Because this is the minimum to get an on-prem Kubernetes cluster running. So are you saying that all on-prem Kubernetes distributions that are put together by yourself without a turnkey solution, such as OpenStack or Red Hat, OpenShift, are they all advanced? If so, okay, I accept. but yeah, so we have to do PKI today. I've been putting this off. I talked about it at the end of the day yesterday, and we're just gonna pray and take a break every once in a while. We are gonna take breaks more frequently. I did not do that yesterday. I did not do it as much as I would have liked. So everyone's using managed clusters. Yep. And I mean, the thing about it is, even if you look, let's say you want to go work for a cloud provider, so you go work for Google and do work in their GKE stuff. You'd have to know all of this stuff. So whether or not you want to work for a Silicon Valley company that's off, or not Silicon Valley because Microsoft isn't there, whether or not you want to go work for a cloud provider and actually understand the underlying infrastructure required to implement Kubernetes, or you want to do your own on-prem, like we talked about last night. Last night I kind of made a decision to stop thinking about air-gapped environments. I keep defaulting to air-gapped architecture, and it is a totally different beast. It is a beast that I want to slay eventually, but it is because, most people that would do on-prem Kubernetes, a lot of them have a high percentage of air-gapped environments because of security and government, stuff like that. But I have to keep telling myself, no, we are going to focus on an environment where the control planes have access to the internet, for example, and stuff. So today, it is yet again is Sunday. That was I don't know if you noticed the time on that, but that was 1 a.m. yesterday we started. And now 12 hours later, here we are again, doing it some more. So, I am actually going to repeat these resources. These resources are actually more relevant to today than yesterday, so I'll move them. And somebody actually found these. If you want to know why I never, okay, I have to tell you a story. It's better to tell you stories. You're going to use easy mode and CR, do the hard way. Obviously the hard way. Which is also the secure way. So here's the story. Yeah, we're going to use openssl from scratch. We're not going to use kubeadm to manage the certs at all. And I have to tell you the story before we get going. So if you rewind story time, right? If you go back like a month, I was like putting everything in place to support this rack, which is now running. That by itself was a pain in the ass, right? Getting all of that stuff running, getting all that infrastructure installed, setting up the networking, the load balancing, the OPFSense or the OpenSense and PFSense and all of that stuff. that took a long time. And after all this stuff was installed, we had to make decisions like what operating system do we put on there, what's going to be enterprisey. We made tough decisions like using Ubuntu server, which we learned yesterday, according to the official spokespeople for consulting in the government and stuff, that actually Ubuntu server fulfills the security requirements. You don't need SC Linux anymore for that. You can use AppArmor, that GKE, in other words, Ubuntu Advantage or Ubuntu Plus or Pro or whatever, actually fulfills security requirements. So I don't feel bad about running Ubuntu server. We're not going to have a religious war about what the best OS for the enterprise is right now, but that was the choice I made. We also discovered this GKE, Google's thing does not support Red Hat, period. So they are running Ubuntu servers internally to run their entire Kubernetes cloud offering. And, so we learned all these things, but along the path, we've also been considering, well, how are we going to deploy this? Are we going to use zero trust architecture? I spent like 2 hours on a decision about whether we were going to even emulate zero trust and try to understand it. We pulled down the document and everything. And so I'm trying to fast forward through the story. And then we get to the point where we're installing Kubernetes. And once again, like I talked about yesterday, it comes down to one thing. It comes down to your command, your kubeadm init command. The kubeadm init command is the one focal point. I'm going to say it again. I said it yesterday. It's the one focal point where all of the decisions come together, because every value you provide to an argument is the result of a decision someplace. And I had a hard time finding, because so backtrack a little bit more. During the whole process, we're going to have to do certs eventually. We have to decide whether we're going to do certs internally or externally, because we had to decide whether we're going to use stacked architecture for etcd. Etcd stacked means that you're running the etcd inside of a static pod that's also running on the control plane node, versus externally, which strictly speaking means etcd is running on a separate machine, even though there has to be a Kubernetes pod. You cannot run etcd without Kubernetes in Kubernetes. It has to be, you have to have it. Anyway, so we went through all that decision. But part of that kind of side conversation all along the way was, how are we going to do our certificates? Certificates are key to this entire thing. They are the ways that everything communicates securely. They're also the core piece of any zero trust initiative, because everything has to have its own identity, and identity is generally managed by certificates. And at that time, everybody was like, "Oh, definitely, you don't ever want to use the internal Kubernetes certifications." Everyone was saying, certificates, and everybody was saying, "Oh, yeah, you never want to do that. Don't use the internal kubeadm certs. Don't use it." Like 5 or 10 people came out of the woodwork in the stream and said, "You absolutely do not want to do it." I'm like, "Well, why?" And like, well, first of all, it's against security policy for most companies. Blah blah blah. You have to set up your own certificate authority. It has to be separated from Kubernetes. You don't want to unnecessarily distribute certs that are core to your enterprise across all of these nodes and everything. And I'm like, none of that is covered whatsoever in the documentation for setting something, not even included in the description of the kubeadm command. There are a couple references to certs like, hey, use this key right here, key used to encrypt the control plane, which, you're going to pass on an argument as a command line argument. No, never. And then you have upload certs and cert directory. Whatever I said. Oh, the idea of not running certs internally inside of Kubernetes. Yeah, well, and this is part of the problem. Not a lot of people can agree on what is the right way to do an on-prem, even for a generic company that I've described. They can't agree on certs. But there seems to be, at least in my chat, there seems to be consensus that certificate management should not be done inside of the cluster for most enterprise size or significant organizations. Need to be on the nodes. Why does it matter how you generate them? I don't know, but the people who are telling us to do it properly, who've consulted with large, governments and organizations, say that it's a bad idea to put the certs inside of Kubernetes. In other words, don't use this. And so yesterday, if you watch the video, you know this, but yesterday during all of this, I was like, well, where is the place where I get to point to the cert like you can with etcd? And you can't. There's no argument to point to the cert. And then somebody posted, I think LBG posted it. EFCA private key published. Yeah. Same kind of KMS. Yeah. And if you have some kind of KMS, key management system, yeah. Otherwise, I don't really get the argument. Well, that's part of the conversation today. We have a long time to go through it. But so I mean, here's the documents. So let's go back to the documents. So this is the document that I think LBG or somebody sent us that talks about key management certificate. As you can see, it's nowhere near the getting started guide. It's not even referred to in the getting started guide, right? I mean, it would have been helpful if this argument right here had said, if there are certificates here, they will be used. In fact, I didn't add it because I was afraid that if I did the kubeadm init, that it would override any existing certificates right there. It turns out that's not true, but that's not documented anywhere in the documentation. It's not in the argument, and it's also not documented in the getting started guide. You have to like dig down into administering a cluster and then look at that to see what's up. Right. And then on top of that, I've also heard that if you use the internal Kubernetes certs, that they will automatically be rotated. But I'm reading right now that that's not true. So we have a lot of research to do today. I also have no idea how to truly manage certs. I know the general concepts of it. But in terms of like tools and command lines and getting good with that kind of stuff, I need to get good with that again. So that's what we're doing today. So here, by the way, this is the guide that we've been following. They renew whenever you upgrade. If managed by kubeadm, yeah, that I've heard that many times. I've also heard that is the reason to use internal kubeadm. But then there's people who have strong disagreement with that. We don't think that you should do that. You should manage your own certs. And apparently, it was enough of an argument to convince my team, who is now all gone. Every single person who created our Kubernetes cluster is now gone from the team. So I am like the last one standing. There's a few people that are there. And one other guy has pretty significant Kubernetes experience, but nothing at this level. And which is, and we had to upgrade from 1.21 to 1.24, possibly 2.6, which has to be done incrementally. You cannot just jump. There's very strong warnings about that. So it's really important that I understand all of this very quickly. Like I have about, a month or two to get it down. Or we're going to get screwed. And on top of that, I have to write, a REST API and a bunch of other stuff and go. But so this is why you're going to see me doing a lot of work on this side. And the thing that annoys me about this is it doesn't even mention certificates at all in the get started page. Not at all. It doesn't mention them at all. But it is mentioned in the other page. So we're going to follow that page, pretending it's in the right place. If you don't want to upgrade, we lost our development cluster for an entire day because the cert expired, because there was no notification and the certs are managed outside of Kubernetes, right? But because probably it's just 1% of the people. What's that? If you don't want to upgrade in a year, like I might do or do not, yeah. I would say the fuck away from openssl and use cfSSL, no. And you need reasonable command line. Yeah, I've heard that cfSSL is better. We actually did evaluate that about a year ago. And I'm using openssl. I hate it, but that's the tool. I can promise you there's no cfSSL on my system at all. So I won't be able to use it. Now I know that I can probably use cfSSL on the system that I'm using to do the management. But if we're going to be forced to use the tools that are installed on these nodes and machines, I'd have to request that cfSSL be installed. So that's actually a good thing to put in the log. A couple of decisions here. Yeah, so we revisited history of how we got to needing cert skills, and I kind of told you that. So the thing I do want to say is I have decided to use openssl and kubeadm cert as tools. So there are a number of tools for doing this, as some have already suggested. And did I put SSH? Oh, whoops. Thank you. And thank you. So the not the same thing, of course. These decisions, when it comes to technology, you have to like chop things all the time, right? And it's super important that we make that. So let's first of all read about PKI, just as an overview. So we were reading about that a little bit before, but we'll do it again. So public key infrastructure refers to tools used to create and manage public keys for encryption, which is a common method for securing data transfer on the internet. So TLS, certs, anytime you see HTTPS, you're talking about encryption, right? You're talking about tunneled encryption as opposed to content encryption. Those are my terms, but GPG is a tool that uses the same kind of architecture, but focuses on encrypting content at rest. And then it's just passed over the internet. We don't care how it gets passed. That's actually how I prefer to secure content. The knowledge exchange grid, I'll plug that. If I ever get to it, it will be based on GPG encryption, and not email is based on GPG encryption. The web is based on tunnel encryption. The problem with tunnel encryption is that any time the hops happen, in between those hops, the content at rest is unencrypted. So, but PKI goes way beyond just web pages. It's way bigger than that. It's now that we have all these APIs, which are just a bunch of JSON flying around and gRPC and stuff, between applications that don't they talk over HTTP, but they send JSON messages back and forth, structured data that way, and they are also secured. And those are microservices fall into that mesh, and that includes grumbles about definition number one. Yeah. PKI is built into all web browsers used today. It helps the security organizations can use it to secure communications. When I went to sleep and I woke up, So we could spend an hour just talking about the definition of PKI, but PKI is a bigger term, which has come to mean, in my opinion, using the method of encryption for more than just the web, even though it's over HTTP. So that includes worldwide web transactions through a browser, but more importantly, as I've said, it includes Kubernetes. So as we've said, the Kubernetes is a big REST API, right? Kubernetes is a big ass REST API, 655, 6443, and you have to secure that. And by default, it creates these, encrypted keys and certificates and resources in order to do all of that. And you have the option, as I've been talking about, to use the stuff that it does automatically for you, or to use stuff that you've set up yourself. And by the way, if you don't know what you're doing, don't set it up yourself. You should get somebody who knows what they're doing, which is why I'm trying to become that guy. Because you can end up really screwing up your enterprise by setting up PKI incorrectly and then making the private keys available and stuff like that. It's basically like it doesn't exist. So, it's really important that we understand that part of it. But for the sake of Kubernetes, we're going to think of PKI in that sense. Now, what I do know about PKI is that you have a certificate authority who is responsible, and I know this from the 90s actually. PKI is really bad, especially if they do the sub certs bad and they put the wrong IP addresses and domains and stuff, not IP domains. When they do the domains wrong, or they just use the star domain in the wrong area, it's so bad, right? So, and it's really hard to fix if you do it bad like that. So we need to think about this. So the basic architecture of it, and if I get this wrong, please correct me. I'm going to go through and review my knowledge of this. But as I understand it today, there's always a public and a private key involved. Okay, and that's the same for GPG. That's the same for any pub key, crypto or method like this. There's always a public and a private key, and I'll just summarize that without any on top of that. There's always a public and a private key. Symmetric encryption means you have one password and you type the password and you pass, or passphrase or whatever. Asymmetric encryption means you have a public and a private key. And to explain that to a beginner, I used to use the term of like the rings of Mordor or something, right? So like the Lord of the Rings, you have one private key to rule them all, and then you have a public key. So you can give the public keys to anyone, right? You give the public keys to anyone. They're flying around, and anything that's encrypted with the private. And I'm going to be really brief on this because I want to get to the learning part, but people need backstory. So, and correct me if I'm wrong, but anything that's encrypted with the private key can be decrypted and read by the public keys. Okay, but you have to have a public key to read it. Anybody with a public key can read it, but you have to have a public key to read it. Okay. And that's like the one key to rule them all. And that's, no, it's public key. It goes both ways. Yeah. And so if you have one of the public keys, anybody with a public key, we're going to get to signatures yet. No, it goes for encryption too. Yeah. But signatures are a different thing. Okay. So since somebody mentioned it, we'll talk about signatures. There's two things you do here. There's signing and there's encryption. They're both different. Okay. Signing is a way to say, I stamped, I did the whole, melted candle on this thing. It's from me. And I promise it's from me. And then anybody who has a public key can verify that it's you. This is why when we do GitHub, what do? You do SSH keygen. You make a public and a private key pair. By the way, SSH uses the same thing, same concepts, just in a different package. And so for GitHub, you do a SSH keygen and you get a public and a private key, and you take the public key and you go onto GitHub, you open the web page or whatever, and you stick it in your list of public keys. And now you can go into there. And by the way, this is the same for if you want to SSH into a system, if you can push your public key to that system and then you can just connect without a passphrase or whatever. I mean, that's how Ansible works in my environment. The public keys are all out there. So, and the ED255 what is it? ED25519, I think it is the preferred signing method these days. It's fast. These all use mathematical algorithms and stuff to do all this stuff. And there's constantly discoveries about things not being secure, RSA, and there's questions about the origins, since most of them were made by the American, government, and whether they're actually secure. I mean, that's a huge topic all by itself. But people generally trust this whole entire infrastructure kind of approach. So you have a private and a public key. Now, anybody who who can encrypt something with the public key that only someone with the private key can read. And so that's another thing, right? So you can imagine you have a club and you have the king of the club, and the king says, hey, I'm going to give you all public keys. You can prove that anything I send is from me, and you can send me secret messages that only I can read, and I can also send you stuff that only you can read if you have the public key. And I mean, but you would never really do that. You can do it, but most people don't, because anybody with the public key can read it. So signing is way more important than encrypting from that perspective. But the creation of like really secure stuff from somebody with the public key that you want to be damn sure that no one can read or see except for the person with the private key, that is something that's pretty commonly done, and that is a part. All of this interaction is a part of the PKI stuff. Now, when we talk about the web, the GPG has I'll talk about GPG for a second. GPG has a problem because why? Because who's to say that public key is actually from that person? Right? This is a problem. I'm going to talk about this for a second, because this problem is the reason for the certificate of authority in the PKI that you see on Kubernetes and everything else, right? So let's say somebody, I mean, you have to figure out how to trust the public key to say that this actually does belong to this person. And, and thinking in terms of humans here. So, and they have signing parties, and you can go up to they used to, back in the day, used to have a signing party. And we would, you would say, hey, please sign my cert to say that, you've seen my face, you know who I am, right? You know that this is me, you know that this public key belongs to me. I mean, it's not unlike, the authentic, check next to a Twitter account or something like that. The person has been validated by an authority, right? A certification authority has said, no, this person is actually who they say they are. This public key belongs to this person, and you can trust that anything that uses that public key belongs to that person or is signed by that person or comes from. It's authentic. Okay, so that step of authenticating the public keys themselves has been a long-standing problem in this entire thing, and this is the reason I think that GPG never really picked up. Because, and you'll see people all the time now, I have friends, it's actually kind of fun. People will put they'll put the reference to their certificate, to their public certificate inside of their Discord profile or their Twitter profile or something like that. Because if they trust that that person is their Twitter person, then they can see that, oh, hey, here's the identifier for their key that they consider their public key, and then they can send it off. Because establishing the authenticity of the key belonging to the person is still the big problem. And just to give you a sense of this, when I was at Nike, when I was at Nike, this is the first time I had any experience with this. I was, the internet webmaster, and I really just wanted the HTTPS. I wanted to be cool. I didn't want HTTP. I wanted HTTPS. I would give a damn about security. I didn't understand it enough. I mean, I did, but not nearly like I understand it now. And there was one authority back then called VeriSign, and that was it. And it was this really, really highly paid. I mean, I think the number was like $2,000 to $3,000 for a cert, and they were the certificate authority. You can go search for them. VeriSign. I think they're still in business, actually. VeriSign is an American company based in Western Virginia, United States. It operates a diverse array of network infrastructure, including 2 of the internet's 13 root name servers. I mean, VeriSign has been around for a long time. The authoritative registry of the .com and .net, the name generic top-level domains of .cc and .tv, country code language domains, blah, blah, blah. So, the PKIs, are they still a large PKI? I think they are. They're still around, right? So yeah, I mean, they've been around since the 90s. They were probably the first. In fact, I think they were the first. Anyway, so this organization, before that, they would give you a certificate, right? Keybase.io. You can also, just before you get to, we do get, somebody put in Letsencrypt. So Letsencrypt has really changed the landscape in terms of like web stuff. So Letsencrypt is a nonprofit that has basically come out as a nonprofit certificate authority run by the Internet Security Research Group that gives you them for free. So they give you them for free. It's the world's largest certificate authority, used by more than 300 million websites with the goal of websites. So this, as I said, the VeriSign was kind of gatekeeping for all the right reasons, really. I mean, including money, but they had to come on site and validate that the person they were corresponding with was actually who they said they were. They had to prove that our organization met some basic criteria. I can't remember what it was. And then they would give us a cert. And when they gave you a cert, they give you the private and the public cert. They give you the private and public key. They would make it for you, and they would give it to you, and it would, it was all fancy and everything. And I mean, you paid a lot of money for that. You'd be damn sure you take care of that private key, right? Because if that private key falls into the bad hands, you're done. But here's what they would do. So I don't remember if they made the private key or if they signed our private key. I can't remember. That's a good question. I don't remember. I remember not knowing enough about it that I just trusted them to give us whatever. And the fact that they're in Virginia makes me kind of scared. So, I mean, really, what I'm getting at, yeah, I think that's probably what they did. I don't know. It was a long time ago. So you have a public and private key pair that's useless because nobody knows that it belongs to you until some worldwide trusted authority signs it. And then when they do their own signing, right? So they're using PKI to sign your pair of certificates. And so they sign your public one and they sign your private one, and they say, as an authorized, signer, by the authority given me, I say that this is legit and it belongs. And anytime you go on a website that has a lock over here, you can actually click here to see the validation of the site. And you can check the certificate if you want. Connection is secure. Learn more. Certificate is valid. Here it gives you your certs and your fingerprints. Organization name, not part of the organization, is not part. What are the details? Common name. And so this here is a certificate authority. This is the organization that you have, or the world has decided to trust, to say that this actually is Kubernetes.io, and then you get your little lock and your green and all that jazz. All right. So that, and you can look at the certificates themselves, and you can see what a big deal they are, who issued it, have PKI cert embedded. Yeah, a lot of browsers do. In fact, if you've ever been to a page, I get this all the time with my openssl router. So let me give you a sense of what happens when you have something that's not been signed. If I go to example.com here, right? Oh wow, it's working now. Oh, see this? You see how it says not secure? Giant list of trusted roots, yeah. And they're root CAs is what they are. They are organizations that the world has decided to trust. In order to get here, though, if you've ever been to a page that says "Warning, this is dangerous," we don't know about this cert. It's because it's using public key cryptography. It's HTTPS. It just has a cert that has not been signed by something that they trust. The only way to fix that, by the way, is to either accept it for yourself or to add it to the list of trusted CAs. And if you're an enterprise, you better make sure to do that. We actually haven't done that on some of the things. It's super annoying because I'll go to the website that I know is a legitimate website because it's internal, and I have to say, yes, this is what I want, because the certs that it uses have been self-signed, or they're not being managed by our internal CA, which our infrastructure team has added to all the web browsers all over the company. And in the case of us, I'm using a Mac and I installed Chrome, which doesn't have any clue about the CA. And so unless I go in and add the certificate authority and the certs for our organization myself, I'll continue to get these annoying "you're not secure" errors, right? So hopefully that's been yeah, hopefully this has been kind of at least an introduction to what certs are for, how they work, and why they have to be authenticated, why you have to have a root authority that says, hey, this cert is good, and how annoying it can be, by the way, when you need to make a new one. And so that brings us to Kubernetes, because in a zero trust environment, everything has an identity. So you can imagine what that means. So that has come to mean, as I understand it, this is where TonyFun can really help me. As I understand it, that means that applications themselves have cert key pairs. They have tokens that are managed. I mean, the whole entire token thing is related to certificates as well. Tokens are, generally speaking, tokens are temporary ways of handling a session more efficiently after PKI was used to create the token for the session. And that's, in a nutshell, that's what's going on underneath the hood as far as I understand it. It's a very, broad strokes kind of definition, but that's what's going on. It's like you use this big fancy, tokens are signed just like Certs does. Yeah. But tokens only live, generally speaking, for a short amount of time, sometimes just for the session that you're having in the browser. Sometimes you have an infinite non-expiring token, like you can use for Twitch IRC if you want to. You can go get one that doesn't expire, which is really bad security, but whatever. And they don't expire. And if you're gonna set up internal Kubernetes logins, which I did for our company, I wrote the Klogin tool that uses Keycloak to generate a temporary token that then gets saved in your kube config, so then you can connect to your cluster. You have to be aware of these things. And then this gets really hairy, because then you got to kind of like dovetails into things like, OIDC and OAuth 2 and all the stuff that people use for authenticating sessions. It's very, very controversial. The person who invented OAuth left the OAuth project when OAuth 2 came up because he was in disgust, because he thought it was so insecure and so bad. So there's lots of controversy about that, but most of it's been already established. How does that relate to Kubernetes? Because we have got to deal with a PKI strategy that is larger than Kubernetes, but that includes Kubernetes. And that is where we are. That's where we start today. So, and that took me like 40 minutes to describe. And that's just trying to get people a handle on what, so they're not just completely scratching their head. An easy way to authenticate, they're not used in the actual protocol. Tokens by that definition, but there is a token used in the Tls Handshake. It's just done internally. Yeah. You get a session token internally, and then it's a different token, but it's still the same word. But strictly speaking, it's the same idea, right? You agree on something, and then you just pass that one thing. Yeah, TLS is very complex, and I know, and I don't want to get it, but yeah, I'm trying to keep us out of those weeds. But it's important that we understand this stuff because the basis of security depends on all of this. So whether you're a hacker, or you just want to set up a safe enterprise environment, or home lab. So you should be familiar with PKI certificates and requirements in Kubernetes. Okay, so let's do that. Client certificates generated by kubeadm expire in 1 year. This page explains how to manage certs for kubeadm. It also covers how to do it. So as LVG mentioned, the preferred default way when enterprise level security is not required is to just use the certificates that are generated by kubeadm internally that get written to etc Kubernetes/PKI, and they expire in a year. Well, if you haven't upgraded your cluster in a year, you're screwed. And we haven't, by the way. It's been like 2 or 3 years. And when your certificates expire, everything stops. If you want to have a massive cluster-wide outage, forget that you got Kubernetes certificate centers, but that happened to us. We had a thing in our dev cluster went down for 24 hours. And everybody's like, what the hell? What's going on here? They went looking in the error logs and went, oh shit, we forgot to renew our certificate. Because they didn't have any reminder set up or anything. It was like total clusterfuck. I mean, it really was literally a clusterfuck. And I mean, that's a technical term, YouTube. And they laughed it off like saying, oh, it's not that big a deal. I'm like, okay. And that was the first time, that was 2 years ago, actually. That was the first time that I realized that managing I had to make a decision. Should we be managing our certificates inside of the cluster or should we not? Your previous employer, it's not fun. Yeah. Because you have to when it's like, I don't know, it's like physical fitness. If you don't do it and you have a heart attack, you're like, fuck. And then you try to recover from the heart attack, you can't because you had a stroke too, and now you can't get your physical fitness back. So it's better to proactively deal with it than it is to have the crisis happen and then try to piece everything back together, because stuff stops very abruptly when the certificates stop working. Continue running, you just can't do anything inside a cluster. Yeah, that's true. They do. It's true. That's a good point. Anything that's actually running and listening on the pods has already been initialized, but you can't do any of your kubectl or any of that. Encrypt is between the kubelet and control plane components, so you're stuck in a read-only until it's fixed. Yeah, exactly. That's exactly what it was too. And that was the symptom. So by the way, if you happen to run into this stuff in your cluster, now troubleshooting. That might be one of the reasons. You might just have certs that expired. So one of the solutions to avoid certs expiring on you is just use the ones that are managed by kubeadm and promise yourself as a company, as an organization, that you're going to upgrade Kubernetes at least once a year. If you're not upgrading Kubernetes at least once a year, don't install Kubernetes. That's the day 2 problem that everybody talks about. But don't do it. If you don't have the infrastructure, if you don't have the people, the skills, and the technical motivation to upgrade Kubernetes at least once a year, it's probably more. You should probably do twice a year. If you don't have that, then just don't install it. Don't. Find something else. It's too much of a hassle. You will hate yourselves for doing it because you have all this expectation on it, and then you won't be able to keep it up. I swear I didn't plan that one. Okay, so before you begin, you should be familiar with PKI certificates and requirements of Kubernetes. So, again, these are all documents that are not linked from the Getting Started guide, but we're going to read them anyway. PKI certificates and requirements. I like that they use non-title case for stuff. It's interesting. TGI Kubernetes, all your certificates have expired. Yeah, we need to, I'm going to queue that one up for sure. Thank you for sending that, LVG. That'll be a fun one to open up. Okay, so let's just read here. It's going to be really boring, my friends, but we have to do it. It's required. Kubernetes requires PKI certificates for authentication over TLS. In case you're wondering, TLS is the new SSL. People from my day, we use the term SSL, secure socket layer, which doesn't exist practically anymore. Nothing dates you more than saying that HTTPS is using SSL under the hood. It's not. It hasn't been for over a decade. So it's using TLS, and you need to know what TLS is. Let's look up the exact translation of that. I think I know what it is, but I don't want to embarrass myself. So what does it actually mean? Transport security layer, SSL 3.1. Yeah. And there we go. So transport security layer is a cryptographic protocol designed to provide communication securely over a computer network. The protocol is widely used in applications such as email, blah, blah, blah. TLS is also used. So we've already talked about APIs, which are basically just JSON requests going back and forth that are secured using TLS. And that's the basis of Kubernetes right now. But modern performant Kubernetes also uses another higher performance protocol called gRPC, which is Google's remote procedure protocol, which is not anything like the stuff of the 90s. In case you're wondering, when I saw the acronym RPC, I got immediate PTSD. It's not the same thing, and it uses protobuf, which is a binary format instead of JSON to communicate. And in order to be secured more quickly, it uses something called mTLS. So that is a highly performant version of TLS that's not running over HTTP. It's running in its own way that I don't fully understand. But I can tell you that it's a very core part of modern Kubernetes. So understanding what TLS is and it's the variation of mTLS is core to understanding Kubernetes internals. gRPC runs in HTTP2, that's right. And it hasn't been fully deployed. I think it runs in Quick too, doesn't it? Is it 2 or 3? Yeah, I personally think the floodgates are just going to burst open when web browsers actually start supporting HTTP2. We'll see, and we could very well see the end of a bunch of JSON on the web because it's just so much better. It's so much better. The same node communication through Unix sockets, and it doesn't use TLS. I mean, it does use TLS if it's cluster to cluster, or in some cases like Talos or Cedero. mTLS is the only way to talk to the machine that's managed under Kubernetes. And that's right, I said machine that's managed under Kubernetes. So Cedero, Talos are, very interesting approaches to managing infrastructure that are not related to Cluster API, by the way, for doing this. But you'll hear the word TLS pop up, mTLS, gRPC, you'll hear that pop up. And just know that it's using under the hood, it's using PKI, it's using this public key cryptography stuff as well. Kubelet talks gRPC with the CRI and CNN. Yeah. Oh, that's right. I forgot about that. Yeah. The internal core infrastructure of the kubelet uses gRPC to talk to other pieces, right? When did they add that? I wonder. I mean, I don't think that was always the case. I think that was added, but trying to get gRPC web working, can't wait for HTTP2. Can you imagine? The web is going to completely change when browsers support HTTP2 because gRPC by itself is going to totally change things. I mean, we're going to start seeing cluster to cluster communication. We could see potentially an internet world of internet facing Kubernetes clusters because they already naturally speak that. And there's no way to deal with, load balancing and stuff better than Kubernetes for that kind of thing. So this technology is as annoying as it is right at the forefront of what might actually be the future of web servers. There could come a time when the idea of a web server turns into a Kubernetes cluster. I mean, it's, we're ways off from that, but if HTTP2, it's microservices, internet facing microservices are already using Kubernetes. So, for better or worse, right? Security problems and stuff. Anyway, so that's TLS. This HTTP, most major browsers had HTTP2 supported by the end of 2020. I think it's HTTP3 or Quick. I don't think it's that HTTP2. Yeah, we're kind of off the rails here, but it's worth looking up. gRPC support in web browsers. It's not supported by web browsers. It's not. Which makes it compatible with HTTP 1.5. It requires the browser app to generate a gRPC client from the profile. Yeah, HTTP3 is the one. I'm pretty sure it's HTTP3. And when you said HTTP2, I thought it was 3, and I didn't correct that. Your browser because gRPC requires HTTP2, and browsers don't expose any APIs that let WASM control HTTP2 requests directly. But there is a solution, is an extension. Quick. I did think I said quick. I said quick. Is not nailed to the wall yet. Yeah. Suffice it to say, there's not browser support for it yet. So the web in our lifetimes, my lifetime, and I'm an old guy, is going to radically change because WASM is coming around. WebAssembly is going to come around, and gRPC will be able to be used inside of WASM applications. And when that happens, the traditional, even the traditional stateful applications that are using WebSockets or stateful HTTP requests or whatever, that's all going to totally change. And you're going to start to see web deployments of massive applications. And they are going to be using gRPC speed to communicate. So, I mean, this stuff is relevant, whether or not you want to learn it for Kubernetes or not. And all of that stuff depends on TLS. It all depends on the public key cryptography that we're going to talk about for Kubernetes. So I guess part of the point of saying all of that is that I'm just trying to make myself feel better that deep diving into PKI is also a crossover education in how public key cryptography even works, because it's at the core of everything that we do and will continue to do. It's a core of zero trust architecture. It's going to be the core of the next version of the web, not Web 3, but the WASM web, you want to say it, call it that way. So it's a big deal. Browser editing and crazy stuff like that. Oh, and anything that's got a performance demand. And we're not talking about streaming in general. It's just anything that's got a high performance demand. Yeah, it's just, there's lots of stuff internally that uses it. I'm trying to think of some applications I know that use gRPC. I know that, there's a crypto shop that uses it. They were on GoTime. They were talking about it. They don't do anything in JSON anymore. It's all gRPC. I mean, it's all gRPC. But I don't think a lot of production, the stuff that gets deployed into Kubernetes a lot of times uses it. But to tell you the truth, we had a choice to use gRPC or to stick with just a plain old REST API. And honestly, 9 times out of 10, I don't have a performance demand that requires the complication of adding gRPC and protobuf. So I can usually just hang on to just a good old fashioned REST API, not even GraphQL. And OpenAPI, of course, has made that easier of a decision. And so we actually went through that. When we did our operational API interfacing with our batch processes from Kubernetes, we seriously considered using gRPC for that. And then we ended up going with OpenAPI and REST because there's really not a performance demand for that level of query. And it does add a certain layer of overhead because you have to write code that has to be compiled into binaries and stuff like that for the gRPC. And so, but I still, it's more performant, and it's no harder to work with than JSON if you have the right tools. And usually in the Go world, that means you're using code generators. And that, yeah, I mean, let's see separate topics. Back to certs. It is a topic I like. That's pulling me into the developer side of my brain. And I do like it. But in fact, I tried to learn gRPC 2 years ago when I was trying to look for a job 2.5 years ago. I told myself I was going to get a job doing gRPC coding in Go. And I actually started making, over-engineering a resume that answered protobuf in protobuf. It was using gRPC. It was really fun. And I learned a lot. But of course I didn't finish it, and I ended up getting a job in the Kubernetes space. But there's a part of me that really wants to go down that path and write those applications. But of course you have to understand the infrastructure you're writing the applications for, in my opinion. Yeah. And that's where we are, which is why I have to understand certs. So they're not fun. It's really hard for me to stay focused, but let's stay focused. If you install Kubernetes with kubeadm, the certificates that your cluster require are, I know it doesn't sound fun. The certificate, we are going to do that, my friends. As soon as we get all these applications stuff running, then we can write software to manage Kubernetes in Go using gRPC and our own endpoints and all kinds of fun stuff, and we can make contributions. But we have to have a really solid infrastructure, and not just that, we have to have a guide that we can agree on for a specific, case study, we'll say, to deploy on-prem Kubernetes. That's not this. This is a pain. It's not correct. It's wrong. It's out of sync. We need to write that. And that to me is a prerequisite to doing some of that other fun stuff. So that motivates me to get this down. And by the way, we need to get close. Okay, so you can generate your own certs, for example, to keep your own private keys more secure by storing them on an API server. And that's what I plan to do. This page explains the certificates that your cluster requires. How certificates are used by your cluster. Kubernetes requires PKI for the following operations. Client certificates for the kubelet to authenticate to the API server. Remember, the kubelet is the thing that runs on all of the nodes, and it phones home to the control plane to do stuff, right? And we already set that up. Kubelet server certificates for the API server to talk to the kubelets. So the kubelet server certificates for the API server to talk to the kubelet. So the API server, I guess, initiates communications with the kubelet as well. The kubelet is sitting there listening. So it looks like two different certs for two different directional communications. I don't know. We're going to find out. The server certificate for the API server endpoint. Okay, so we have a server certificate for the API that's sending out REST requests. That's very much like a regular good old web server. Kubelet server certificates for the API server to talk to the kubelets. Okay, so this is interesting. So we can infer from this that kubelets behave as servers on the node. And that makes sense because things are initiating communication with the kubelet, right? It's not like the kubelet is always connected, right? Or phoning home every once in a while and doing kind of a pull architecture. It's because the kubelet is sitting there listening, however, and it's functioning as a web server on each node to listen for incoming commands and work to be done from the control plane. So it has a server. Okay, so that's good to know. So the kubelet, you can think of the kubelet as being a web server-ish, and you can think of the API endpoints being servers. Both of them, you can send requests to them, for REST API communication. In the case of the kubelet, you would never be sending anything to the kubelet, but you would definitely be sending things to the API endpoint server. You're going to do that all the time. Your applications are going to do that outside of the cluster kubectl. That's exactly what it does. To make file driving SSL to Mint. Wow, that's cool. And client certificates for administrators of the cluster to authenticate to the API server. Okay, so I happen to know for a fact because I wrote this code, not for Kubernetes, but for our enterprise, that does this. And that is one of five different ways to authenticate to Kubernetes. And it's probably worth mentioning that really quickly. There is the completely wrong way to authenticate to Kubernetes that I am doing right now by copying the one certificate to rule them all admin.and the admin.conf file and using that to connect. That is one of the many of the 5 ways. It's also the way that you should never do. If you do that, you are violating all kinds of security by doing that. It bypasses all admission controllers, all RBAC and everything. And there's like 4 other ways to do this. There's, setting up accounts on the machine. I'm simplifying, but setting up accounts. You can also give your administrators their own cert. This is very much like SSH. If you were going to allow an administrator to go onto a specific machine, you would ask them for their public key, and they would generate a private public key pair, and you would put that public key in the application, and then they could connect, right? And we could track that person actually. And you could do exactly the same thing using the TLS certs. It's just a different implementation. So client certificates for administrators of the cluster to authenticate to the API server. And then you have client certificates for the API server to talk to the kubelets. Okay. I have to think about this. So let's go back to the components really quick. So you can see, I hate this diagram, but this is the official diagram. So I'm going to pull it up. If you search for components in the official docs, you can see it. So what we have is So anything that's these arrows are misleading because they show the arrows are pointing into the API servers. Well, we just read that that's not how the interaction works, right? It's not. The kubelet is responsible for inbound access, asking the API servers to answer. But these things here, I don't even think these arrows, I think that there's actually arrows directly from these things to these things pointing out. I think this suggests that only the API server is interacting, and I think that's wrong, because we just read that the kubelet has a server on it, and it has a certificate, and it wouldn't have a certificate, and there wouldn't be an API server client certificate if this was not initiating a connection to the kubelet to tell it what to do. And we don't think of that coming from the API server. We think of it coming from the scheduler. The scheduler is the thing that says, hey, I got work for you to do, and it sends a connection over to the API server over gRPC, and the APIs, and none of that is captured in this diagram, which is really sad, because strictly speaking, it's not specified that it has to be that way. And that's another thing I don't like about the Kubernetes project entirely, is they refuse to say the details of how it's actually done. They say, this is how the specification says it should be done. Everything internode is HTTP. Yeah. The individual lines are pretty complicated. They are. So the scheduler says, hey, I got work for you. And it pushes to the API server. That is gRPC. It's like, it's on the machine. These are both on the control plane. And these are both static pods, I just found out yesterday, 2 days ago. And that goes to here. And then this initiates the connection to the kubelet. Tells the kubelet, you got work here. Here it is. And gives it work. And then the kubelet goes off and does it work. When the kubelet does its work, it phones home. And then the kubelet is also, I think it's the controller manager over here that's regularly saying, hey, tell us about your health. And it says, give us your health. And the kubelet's like, okay, here's my health. And then it jams it in etcd under the status section of the stuff that you get from getpod. So people ignore the status section of there's three parts to a YAML file. When you do like a get pods or something like that, there's actually three parts to it. There's, the metadata, there's the main data, the state data, I guess. And then you have the status data, and the status data is always overlooked, but that is a part of the specification. The status data only lives in etcd. But otherwise it's the same. And then that's a Kubernetes detail that people may not know about yet, but I'm assuming you know a little bit about Kubernetes at that point. The API connects back to the kubelet for logs and execs. Yeah, so getting this communication, the details are kind of inaccurate. Well, I don't know about the details of the communication, but it is true that there's a server. You can think of the kubelet as being a server. There's a client over here and there's a server. The kubelet acts as a client and it acts as a server. Sometimes it initiates communication with the API server, and in that case, it's acting like a client. And sometimes the API server initiates communication with the kubelet. Is it safe to say, by the way, that only the API server is initiating communication with the kubelet? I've heard that said before. I've read that, and this diagram would suggest that. But I don't think there's any other component. The API connects back to the kubelet for logs and exec. Yep. And that would be the API server, but that's not the answer to my question. My question is, does anything else communicate directly to the kubelet? And I'm pretty sure the answer to that is no. Okay. So what we're saying is that these things here do not have, whatever internal infrastructure code would be required to initiate an HTTP connection directly to the kubelet. That code is in the API server only, and that all of these components, all components just talk just to the API server, but these internal components, although it's not specifically defined by Kubernetes, they are all really interested in communicating at high speed with the API server, which is why you should have all of these components on a single machine, a single control plane node, and so that they can do that communication. As I understand it, as I said before, these are static. Most of these are static pods, and they are communicating over gRPC directly to the API server, which is extremely high speed. And then the API server is doing the grunt work of doing the question. For new questions. If the new questions are related to Kubernetes, yes, and certs, yes. They're doing HTTP? No, they're not. I know at least one of them's not doing HTTP. Internode communication is HTTP. This is not internode, but internal node communication is not HTTP. I know that's not true. Yeah, I've seen some of that code. Some of the communication is I was going to say. So doesn't CNI count though? Yeah, just CNI, CRI, CSI, gRPC. That's what I'm saying, and I've been saying that. This communication is happening inside of a node. The thing they don't show you here is that all of these little blue boxes are running on the same machine. At least they should be. If you put etcd on an external server, I imagine that communication is unfortunately HTTP. Do you think that's still an HTTP? These are not nodes, by the way. So this etcd could be on a node by itself if you do an external architecture for etcd, but it doesn't have to be. It's usually stacked in a pod. I mean, I think what you're suggesting is that pod-to-pod communication in the control plane is over HTTP, and I'm not convinced of that. But that was my initial understanding. But I've seen stuff. Server is HTTP REST. Yeah, but I don't think that's the only way to communicate with the API server. Yeah, I know, but I could be okay. Yeah. Obviously, the API server speaks REST, but I don't know. Maybe it's something I was reading about, but I think that there are API server implementations that actually talk in a more performant way to this stuff that don't use REST, because they're on the same machine. So I don't know. I don't know. If not, I think there's a movement towards doing that. I think there's a movement towards the mTLS gRPC communication between internal control plane nodes, pods. But I don't know. So suffice it to say, so the API acts as a client. The API pod, if you will, static pod, acts like an HTTP client to do a REST request to a kubelet, and then we have the kubelet, which sometimes acts as a server and sometimes acts as a client, and it can make REST HTTP requests, secured REST HTTP requests to the API server and the API server only. Now, that request gets routed to the virtual IP that we set up earlier so that it may go to any one of the API servers, which are in my case, one of 3 different machines that are that are redundant. And the backend internals of how the responses and the interaction happen does not care if it goes to a different server. And the application has been architected so that you can have 5 of them, which is common in production. And as long as the kubelet only has to know, do more breaks today. Okay, I need a break. So yeah, the kubelet does an initial. The kubelet only needs to know about one address. It just needs to know, and that could be a domain name actually. And then it gets load balanced to whatever the load balancer decides. So if you wanted to put the load balancer, it would be right there. It could either be a physical load balancer right here, or it could be like a software-based load balancer that runs on the endpoints like Kubevert. It's like Kube VIP. All right, let's take a break. And we'll come back to this. I know it sounds like I'm not even breathing, right? But I want you to understand too, the reason I'm overstating and restating like that is because I'm solidifying my own knowledge as I go. That's part of the repetition for me, and it's not particularly fun to watch, but that's how I learn. And so this explanation of how things are working, somebody called it the Feynman technique the other day. I'm kind of explaining it to myself as I explain it to you, or try to explain it to you, as a way to solidify my knowledge of it, because it's core knowledge and I really need to have it. So let's take a break. Okay, so we had a nice break, and we are back. Went outside. It's a beautiful day out there. Great fall colors. I might do an IRL stream, just go walk through the neighborhood later today, just because it's so pretty outside. I need the fresh air after doing, all of this in my data center and /bedroom. It's not really a bedroom. My main bedroom's the other one. And we're back to the open. We need a break. You know what? Let's set up Pomo. Z Pomo start. Let's keep with the 58 minute. I don't know why where that number came from. It originally started with Twitch. We're gonna observe our little Pomo thing here and take breaks. I don't know how long this is gonna go, honestly. I need to get it done though. MIT found a way to retain models on a small 256K chips. Ooh. Distributed like that would be super interesting. All right. Where are the certificates stored? Certificates are stored in etcpk Kubernetes PKI. We know that because we read the arguments, and you can change that. All paths in this documentation are relative to that directory, with the exception of the user account certificates with kubeadm places in etc Kubernetes. Wait. Let's read about the certificate types. I kind of got sidetracked there. I want to review every certificate and what it is used for again. I want to have this memorized. I want to have this totally committed to memory based on visualizing how the clusters communicate, how the API clusters, pods talk to each other. I want to be able to reproduce this at will. So here we go. We've got, as we were reading before, I'm going to review it one more time. We have the client certificate for the kubelet to authenticate to the API server. So that's the kubelet. Once again, that's the kubelet acting like a client, a web client, initiating a REST API request to the API server listening on 6443 and load balanced across whatever load balancer solution you have right here. We have Kube VIP, which uses ARP to use a single virtual IP to point to any one of 3 actual machines. So initiated connections, that's what's happening there. And then we have the kubelet server certificate, which, hey, thanks for the follow, Russ. So the server certificate for the API server to talk to the kubelets. So even though it says server, in this case, there is a client built into the API server. There's an HTTP client built into the API server that initiates a connection to the kubelet. Now, it's important to note that the API server, the API pods, we'll say, components, they are pods. So let's call them what they are. They're pods. The API pods are also answering as servers. They're answering the kubelet for requests. They're also answering requests over REST from etcd and etcm and all this stuff. And then it brokers that request by making its own request, initiated request, out to the kubelet. There's no load balancing or anything going on. The routing is internal, and it's based on core DNS, which we haven't got to yet, in order to find the kubelet. So, and the kubelet is I do wonder about that though, actually. How is it going out? How does it finding the kubelet IP address? The kubelet registered itself, and so now it knows what IP to go to, and it probably initiates a direct connection to that IP, which doesn't change. These are external IPs. I imagine it's. I don't think it's a virtual. Is it a virtual network? Is it a self-signed cert? And there's a pretty convoluted way to fix that. Yeah. So, in terms of networking, what is the API server initiating a connection with? Is it so the kubelet registers? When you join, it tells etcd where to contact it, and the API server knows what IP to go to, and it always goes to that API. And that kind of so that has got to be its IP when it registers. Are we talking about its IP that I could actually SSH into as well? I'm pretty sure it is. How could you look that up? If I did a describe on it, would it show it? I mean, this is going to come into play when we start doing the certs, because the certs have to have some kind of identifier on them. Yeah. Okay. Let me try that. I just really want to see that. So, okay, get PO pod -A. So we have kind. Oh, that's it. Oh no, wait. This is weird. Why does this have kind in here? etcd control plane. Oh, PO. Yeah, not pods, the nodes, of course. nodes dash o wide. Okay, there we go. So it's a 172.18. So interesting. That's the kind control plane. This is totally different. Why is this using kind? I gotta, that's not right. That's not right. I'm screwed up there. Yeah, this is a totally different thing. Yeah, I know. I know. Give me a sec. As soon as I saw kind, I was like, that's the only cluster we have. Yeah. No, I'm not using that. Not until I use the other stuff first. That's not a standard tool. It's a good tool, but it's just not standard. Besides, I don't like it anyway. No, I built all that in my Klogin tool. I built context switching in my Klogin tool instead of using that because I already have to have a custom tool to do logins properly using Keycloak. I'm trying to figure out what's the fastest way to do this. Let's just go straight here. This isn't going to work because I'm not authenticated. Export cube config equals etc Kubernetes admin.conf. This is a way to get your stuff to work until you're actually fixed. Get nodes dash o wide. Permission denied. Oh, because I'm not root. I don't do K9S, no. No, why? You're not going to have those in the production. You can use them if you want. I just think people reach for tools too early. I mean, if you don't know how to use all the kubectl, including all the context stuff, and you start to use the tool that keeps you from remembering those things, you're hurting yourself. You might be able to do certain things faster, but you're overall you're hurting your knowledge. I find that DevOps people tend to reach for that stuff more than infrastructure engineers. They just deal with what they have. They do the right thing. That's my opinion. They're like, the DevOps people are always out for a new tool. They're also the people that use NeoVim and Z Shell and shit. And they're usually not good infrastructure engineers, bottom line. That's been my experience. So if you have dozens of clusters, I could maybe be convinced that that's true. Yeah, you might need another layer of tooling. I mean, but let me enter Exhibit A. There's no listing of K9S anywhere in the Cloud Native Foundation because it's, a minor project. It's cool, and I know a lot of people who use it. I just think people use it prematurely. And I only have 3 clusters to administer, so that's not an issue yet. If I had more, I'd probably be more on board with that. Yeah. Plus, I mean, as long as you have... Yeah, another thing, too, is we have... Most of our infrastructure, they force you to use a jump box to even access kubectl. So if you have a properly set up infrastructure where you can access it from your home system, and yeah, go for it. Go, you can do whatever you want. You know. Can't get no. Yeah, 192.168.42. So okay, so that's good. That answered my question right there. So it's using the actual IP addresses. It's using the actual IP addresses. This is interesting. It doesn't have external IP. That would be like the load balancer or the services or something. I find that interesting that it considers these IPs internal. I mean, they are, but I guess the external would be if I wanted to set up a load balancer and have that, not a load balancer, a server. I mean, it is a load balancer, but. Get to know name dash o YAML. Oh, that I know. I know how to look up stuff about a node. I've been doing that for 2 years. External is only used with cloud providers. That's not true. I've been able to set up. We've done it before. You can set up external. You just have to set it up. You have to do it. You have to set up a cloud provider. You have to basically fill in that hole in your local on-prem stuff. That's a cloud provider. Istio will give you an external IP. I've used that before. So, yeah. Let's see here. Anyway, so that answered my question. I'm satisfied. Confirmed that Kubelet IP used by API client in server is 192.168 is what do we want to call it? Is assigned by network outside of Kubernetes. So that's like the outermost layer in Etsy hosts in my case today. Okay, so mTLB, yep. But I don't have to use mTLB because I use QVIP, which apparently fulfills the role of mTLB. I haven't done MASS, no, but we're talking about certs right now. So, let's see. External IP addresses for Nova Kubelet. I mean, I've seen it. We have clusters in our internal network that have external IPs. So I don't know how they're doing it, but we definitely have that. I'll have to go reconfirm just to make sure, but I know we have that internally. I thought it was Istio and mTLB that were fulfilling that, but for nodes, yeah. Yep. I mean, it's possible I confused it. I was looking for services instead of a node. Same fields, right? That's very possible. I'll make a note to fix that. I'm going to make a note to fix that. Need to confirm external IP is only for cloud providers. Yeah. It's a node. I need to look that up. It's dot speedy. All right, so okay, back to the certs, back to cert land. Okay, so we're iterating through all of the certificates that have to be managed for Kubernetes to work. And how many of them are there? So let's quiz each other. How many certs are there, and can you name them? Can you name the certs, the key certs that must be managed in your cluster? Offhand. It's kind of a personal study group test here. So we have the server cert for the API to initiate a connection to the kubelet. I'm sorry, no, we have the client cert. No, they're not going to show in this diagram. Absolutely not. But this is the best that we got for now. So we have the client cert that's going to act like a client talking to the server kubelet. So that's two certs. We have a client cert here, and we have a server cert for the kubelet. The kubelet itself also initiates a connection to the API server, kind of a reverse way. And it has a client cert, and the API server has a server cert. I know that's confusing, but they have a pair of certs for initiating connection to one another. That's not auth with certs. It just said it was, so I tend to agree the docs on this one. I'll read it to you. API to kubelet, it says right here. The client certificates for the API server to talk to the client, to the kubelets. That infers that the API server contains an HTTP client that is TLS authenticated that uses a cert to initiate a connection to the kubelet. If this, unless I'm misinterpreting that line says there is a cert for the client when the API server acts as a client. It might be another piece there, but that's how I interpret. I mean, the docs have been wrong before, so if you have something to add, please let me know. I mean, obviously we're going to find out because we're going to add all these things. So how many of these did we get? I got most of them. The other ones I haven't read about yet. So we got the client certificates for the kubelet to authenticate to the server. So that's kubelet initiated communications to the API server. So we have a client cert and a server cert. So here we go. We have the client certificates for a kubelet to authenticate to the API server. And then we have a kubelet server. So this is when the kubelet acts like a server. We were talking about that. For the API server to talk to the kubelet. And that means that the API server also has a client cert because it has to act like it was sitting there. If you can imagine a person, the API server sometimes is like going to the website that happens to be on the kubelet. And then the server cert for the API server endpoint. Now, this server certificate for the server endpoint is the one that's load balanced. So this is maybe going to be different, right? Because this cert, it will be the same cert for all API server endpoints. And that's one I don't quite have my head around yet. I get the client to server, server to client pairs, but this is a kind of a different beast. Client certificates for administrators. Okay, that's just authentication stuff. That's like their keys to get into the server. I should have probably guessed that one. A client certs for the API to talk to kubelets. We talked about that. For the API server to talk to etcd. Okay, so we need to talk to etcd. I know about these because when you do etcd backup, you have to provide these on the command line. You have to provide full paths to these on the command line. That's in the backup script that I'm supposed to be rewriting. And these include all IPs and host names. It can be accessed through the API server cert. So this is a big ass one. Yeah. This is the one that's like, okay, you are all authenticated to talk to me. Okay. And then we have the client certificate for the API server to talk to etcd. So this has to exist because etcd might not be stacked. It might be on a separate machine. So even when it is stacked and it's running inside a static pod, it still has to communicate and it still has to use, apparently, that's got to be slow. That's got to be a source of latency, I'm guessing, because it has to do authentication. It has to do REST API request to etcd. That's got to be a latency issue. Of course, etcd performance is primarily based on disk writes. We read that from the etcd site, and that's why I upgraded to 3600 IOPS SSDs for my control plane, as opposed to like 800, which I had on my Mac Minis, which are hard drives. So client certificates, client certificate key config for the controller manager to talk to the API server. Oh, well, that would suggest there's your REST confirmation LBG. Unless it's using mTLS for that. Only had a little balancers. Yeah. So, video cluster, there was no external IP TLI. Yeah. Yeah. Yes. So, client certificate kubeconfig for the controller manager to talk to the API server. The client certificate kubeconfig for the controller manager to talk to the API server. Client certificate config kubeconfig for the controller manager to talk to the API server. Controller manager is the thing that loads all the controllers. It runs, I think it runs RBOK too, if I remember right. It has it's that piece of the brain. This is the cloud controller manager, and that only exists in the cluster if there's an external cloud provider, and that might be an explanation for not having external IPs assigned. If you do not have a cloud controller manager, I think it's probably safe to say you're not going to have the external IP thing. Although I swear to God I saw it. So we're going to go research that later. The controller over here, the controller manager is talking to the API servers.
Bye.
Bye.
We're in the same thing I on yesterday.
God, you're hot. I mean,
your eggs because they were there for a really long time.
Okay, that's fine.
I totally forgot I made us hash browns, so I don't know.
I forgot I had eggs and I ate something else.
Okay.
Also made coffee. Bye,
yeah.
Doris.
All right.
They're saying bye. I like your headband thing. Makes you look pixie-like.
Thanks.
It does. It's very cute.
Thanks.
Plus, it keeps your hair out of your face while you're like leaning over doing. Like.
Did I tell you I found a total workaround? So Milan wants to put my thumper piece in that show, which I never finished with the Arduino.
You're getting recorded, so careful.
Okay.
I have to warn you.
I
Just.
know. But in the meantime.
Yeah.
They've made the technology so easy. I just ordered a kit on Amazon, actually 2 different ones to try them out for like each were under $20.
Wow.
And then I don't have to do any of that coding and figuring.
Really?
It's all the only thing I'm probably going to do is swap out the light sensor for the motion sensor because
I want to see that project when you do that when you're done. It's very, very technical. You're putting technical stuff in her art.
Yes.
Sam, are you here
like
for
worst
good?
Case scenario, I was just going to have it broken because that's how I felt about the whole original idea of having them say things and it makes sense. It might still do it just broken.
Yeah.
Because the whole idea of Thumper's rule is if you don't have anything nice to say, don't say anything at all. And they don't have anything nice to say, the politicians.
Yeah. I like it. It would like shock you with saying something that would.
Well, I was thinking about this is what I'm going to do.
Yeah.
I'm going to try to have it make a sound, but it be like garbled, like it is broken.
A garbled sound, like it's broken,
Yeah.
and then like your art's broken. I'm like, no,
right, exactly.
that's.
Because
If you do that, you got to make at least one random sound that's not broken. Yeah. It's like I'm not broken.
Well, no, I want it to be like it'll talk and then it'll go.
Yeah. Oh, yeah. That's wonderful.
We'll see. But worst
I
case
can't
scenario, if I just get fed up, it'll just be broken and that's the piece.
Yeah.
And I'm okay with that.
My wife's got her work clothes on. She's off to the.
I'm off to the mines.
To the mines. Yes. What are we doing? We're working. I swear.
Our second disc is coming today.
Oh yeah, finally she's getting another disc,
Yeah.
like the other ones.
And just stir the bean soup every once in a while, even if you don't eat it, like when you walk in the kitchen.
I'll certainly try to do that.
Okay.
I can't promise anything, but I will do my best.
Well, I figure if I tell both of you, my chances.
That you're higher. Or send me a text. That's another thing.
Just stir the bean.
I love her. She's fantastic. Oh yeah, she's so great. So is my dad. Look at this gut on me, Matt. I gotta go running, dude. This is the thing. I can either build this or this. You can't build them at the same time. You can't focus. You can't focus. You got your bike out? God bless you. God bless you. I want my bike, Doris. I wanna ride my bicycle. All right, back to control. Maybe I can get done with this early enough to go out and get some actual exercise. Oh, I know. It's the fall, Matt. That's what I need. You need to like torment me with all the fun you're having outdoors while I'm indoors in my cave writing code and doing shit. Because then maybe I'll get out, and get some exercise. It's hard though because there's only so many hours in the day. This is why you don't see people Twitch streaming that have jobs. They don't. So I have some interesting voice program. Yeah. I mean, you can do a lot walking. I mean, I used to do most of my coding while on a big hike. I would hike from Davidson to Mooresville on a big old walk, and I would take a paper and pencil, and I would write. And sometimes I would compose. I would like write blogs and stuff, with my phone because of AI. You can like do a lot of note taking, stuff like that. So that I mean, like writing a book, like putting all these thoughts that we're having together into a book that could guide other people that want to build Kubernetes clusters. That's the kind of thing I can do while I'm out on a walk. And then you get all the benefits of, I mean, going outside after you've been in a cave like this for a while, just the air, you can tell the air is better. I've authored a couple books and I just don't ever follow through. Story of my life. Because I'm like, this thing could be out of date. It's going to be out of date as soon as it hits the press. I'm like, we'll make an ebook. And I'm like, okay. There's other people who like rush ebooks out and spend more time focusing on books and stuff than actually, I don't know, learning things and doing things. And I'm not that person. I'm not. I'd rather talk about everything, which I obviously do. Anyway, so we almost got all our certificates. So we just found out about another certificate. There's a certificate that talks from the controller manager to the API, which would confirm LBG's statement that all communications between pods on the control plane, static or otherwise, is through REST. Otherwise, there wouldn't be a certificate for it. I mean, well, that's not completely true because mTLS can use the certificates without using REST. So there may still be some gRPC there that we're unaware of, right? And I still want to look at that. What I want to know is I wanted to do this for a long time. First of all, when I first saw this stupid diagram, I wanted to know, what do these things represent? I now know that in pretty much every case, these things are static pods running on a single control plane node that are replicated or duplicated on each control plane redundant node. That's not completely obvious. The method of communication is also not completely obvious. I know that at one point, everything that communicates with the API server all communication went through the API server, and it was always based on REST originally. But I have a hunch that some of this internal control plane communication is now being done over gRPC, and the statement that the controller manager talking to the API server needing a cert is not proof that it's doing that. Multiple TLS, meaning both client and server checking each other's certs. Oh, really? I didn't realize that. So the question is, just because something has a cert doesn't mean it's using REST, right? Because we know that there are mTLS deployments that use gRPC that is not REST. So it's possible that modern Kubernetes has upped its game internally and has a little bit of gRPC going on in the communication. I don't know. That would be a question for Tony Farr, maybe Chris Nova or somebody. You know that's for sure. You know that's for sure, huh? I swear I've seen a little bit of that, though. You're saying it's only the CNI that's doing all of that. The plugins are the low-level plugins are the only things doing that kind of stuff. Okay, well, I'll trust you for now until we get evidence. We do know that it uses TLS because otherwise it wouldn't be a cert for it. And because it has TLS, there's a high likelihood that it's at least REST, if not, I mean, I saw some gRPC code in there somewhere. I can't remember where it was. It might have been the CLI. Anyway. Both exchange certs and verify. An impression, all internal comms do that, but I may have misunderstood what I read. The same API exposed over both REST and gRPC? Yeah, it does. For performance, hell yeah, it does. Yeah, in fact, I think the team is moving towards that if it's not already there. Yeah. Still playing TLS. Yep. Client certificate config for controller manager to talk to the API server. Client certificate for the API server to talk to etcd. I mean, just the latency to use REST to talk to etcd is ridiculously slow. That right there, just that one thing could seriously benefit from gRPC. Client certificate kubeconfig for the controller manager. In fact, I want to say that is gRPC these days. I swear to God, one of them is. Client certificate kubeconfig for the controller manager to talk to the API server. Okay, so yeah. Client certificate kubeconfig controller manager to talk to the API server. Okay. Certificate and a kubeconfig for the scheduler to talk to the API server, and a client server certificates for the front proxy. I think this is the Istio thing. Yeah, the front proxy is like the Istio. It's like the inbound thing into the entire cluster, if I remember right. Yeah, authentication flow. API server. Oh yeah, when you have problems. Not faster than REST over HTTP2 by default, but it gives you tools to make it faster. Is not faster than REST over HTTP2 by default. Huh. Interesting. I'm gonna put that in my log to go read. That is not my understanding of gRPC. But I mean, it is a Stack Exchange question. Selected message compression. Yeah. gRPC a streaming RPC can a streaming RPC, which is different. You can turn off compression for the images if compressing already compressed data. Class load balancing, well, not improving. gRPC can intelligent backend is that, yeah. Heavily optimized gRPC is under continuous benchmarks to ensure that there are no speed regressions. You will see most of your performance improvement just for using protobuf, right? Well, you could use protobuf with REST. It's very nice to integrate with gRPC. Technically, you could use JSON with gRPC. Most people don't. I mean, a protobuf is the one I'm talking about. Most people don't want to pay the performance cost of getting used to Protos. You could use JSON with gRPC. Yeah, I mean, I suppose that's fine. gRPC doesn't mean protobuf, doesn't imply it, but it normally follows that. That's what you're using. Yeah, I mean, we'll come back to that later. gRPC is a pain in the ass. Protobuf is a pain in the ass to implement compared to REST for sure, for definite sure. So, I mean, that's kind of a different conversation, but it is important. Type safety implications, yes. Yeah, that's a huge advantage over protobuf. Protobuf over JSON fucking schema. It's horrible. JSON schema is so bad, I have no words to say further things about that. We're getting burned by it really bad right now because OpenAPI decided to use it to define itself, and it's totally lacking. User makes a request to the Kube API server running. There's no way to define composition in JSON schema. It's totally brain dead. The caller doing the encoding makes it easier to decode the server. Yeah. So welcome to the Swimlanes. We don't want to do authentication flow right now. We don't need to know that. So did I kill my PKI? There it is. Okay. So this would appear, I mean, we'll assume it's all REST and it's all talking, it all has servers. All the pieces that are talking to each other all have their own certs, which is kind of reminiscent of Zero Trust. Like all the things that talk have their own identities and their own credentials. And that would imply that that's what's happening there. Front proxy certificates are required only if you run kubeproxy to support an extension API server. We do not do that. etcd also implements mutual TLS to authenticate clients and peers. Aha. So it does do mTLS. I wonder how you opt in to use that, or if it uses it by default. Anyway, where certificates are stored. If you install, we have 25 minutes left for this pommel. If you install Kubernetes with kubeadm, most certificates are stored in Kubernetes PKI. We know that. All paths in this document are relative to that. User account certs are in etc Kubernetes. So, and by the way, you hand those out to your users and say, be careful, don't lose this. It's basically like giving passwords or SSH keys out to people. And you don't do that normally in a large infrastructure deployment, right? Especially if you have a lot of customers that are using Kubernetes, which we do. We have a bunch of developers who are using Kubernetes who need access to run jobs and stuff. And, you know, kubectl kind of access. And giving them all certificates that are generated is really stupid. So we use service accounts for that. And, you know, individual token authentication for that kind of thing. It gets refreshed and it's all managed through Keycloak. So yeah, it's not related to gRPC. Yes, it is. Most gRPC travels over mTLS. So that's why they get mentioned together. There's not a dependency on it, but so they're related though. You know how many times, every time I see gRPC, it's mTLS plus gRPC. They're two separate things, obviously, but they're always written in the same sentence. I know. I knew it was TLS. I didn't know it was multiple TLS. I didn't know that was the M was for. It's just TLS. It's just gRPC over TLS. The end. Yeah, apparently it's a way to do it without having each system have its own cert, like Kubernetes is obviously doing. It does make me wonder why they're not doing mutual TLS between the API and kubelets. Mutual TLS. Do you think the kubelet and the API at some point might implement mutual TLS versus each of them having their own server and client certs? Because that seems like that's the goal of mutual TLS. I don't know. I haven't studied it at all. Let's go read about it. Mutual TLS, mTLS for short, is a method of mutual authentication. mTLS is the parties at each of the end of the network connection have. They claim to be verified. They all need certain keys for mTLS. I know, but we're talking about both sides of it. Does mTLS have the same requirement for a client and a server? I'm guessing it does. Right. Well, in that case, you could say that I mean, strictly speaking, the Kubelet API communication is using mTLS because that's exactly what it has. Is there something to the codification of mTLS that says, you know, when the server also verifies the client? Oh, so it has an extra step. I see. Because right now it doesn't. Right now, Kubelet initiates the connection with the API server, and the server doesn't do any validation that client is going to be able to receive a request later as a server. To get around authentication, server takes client certs as an authentication. Yeah. Oh, wow. Is that what it is? That makes so much sense to me now. That one sentence really broke through for me. That is really cool, actually. Yeah. Yeah. Server takes client cert as authentication. So then we don't have the two sets of cert. I mean, you have them, but they're sort of grouped more tightly. The server doesn't care about the client certs. Right. And that is the architecture of a kubelet talking to an API server right now. That's why I'm asking why they haven't moved to mTLS there. Or if it's just portrayed poorly and it's actually using mTLS. And because I mean that's what we have here, right? We have the cert. Where is it? We have the client cert, we have both the client and the server in the API, and the client and the server certs in the kubelet. But because it's not submitting its client cert to the server as authentication, it doesn't qualify as mTLS. It's traditional server client authentication. It's just redundant because you have the two things. The first point makes it TLS. Yeah. Yeah, the kubelet gets the client cert registration. That I know. Yeah. But there's nothing about the API server that knows that client can submit itself. So Kubelet to API is also mTLS. I don't know that that's true because it doesn't use its client cert for authentication according to Computer Nerd. It's signed by the same CA. Oh, it actually does do that. So what you're suggesting, so I want to be clear here. What you're suggesting is that the communication between the kubelet and the API server is mTLS. It's mutual TLS because there are two certs on both sides that know about each other and that use each other to authenticate. Even though it's making a server request, it uses its client ID as identification. Components is mTLS. What I read suggested to me that mTLS is for all internal comms with the internal CA. Huh. True or false? The communication between the API server and the kubelet in either direction constitutes mTLS. It sounds like the answer is yes to me. From what you were saying. That's what I want to validate with Tonyfall though. But it's done with different certs. Yeah. What do you mean it's done with different certs? I thought the requirement for it to be mTLS is that it be to be knowledgeable of the cert. They both have a client and a server serve for each other. To me, that's the definition of mTLS. It's two different channels, so that's not mTLS. That's what I've been trying to get at. I don't think it's mTLS because, yeah, I know how it talks. That I got, right? But it's technically, if you're sure that so what makes it mTLS versus just a client-server interaction? As somebody said, the server takes the client's cert as authentication. Authentication, not just the socket, right? Not just for the socket communication, which is normally all TLS is involved in. It says, no, this is who it says it is, and it has some semblance of, it says some knowledge of the identity of the thing that's initiating the connection. It uses a cert for more than just TLS on the web, right? The server verifies the client cert. That's what I'm getting at. So that makes sense to me if that's true. It's like, okay, hey, since we're talking to each other here, it's not just one way. Since we're talking to each other, let's just to agree to know about each other, and then we'll pre-authenticate. And then it probably saves a bunch of session handles or stuff like that too, because I can just use the cert for it. Yeah. That is not it. Oh God. Client access control list. You just send the message. Yeah. Okay. When you use search, yeah. So that helps. TLS handshake protocol. I know about that part. TLS handshake protocol. That is mutual TLS. The TLS handshake certificate request message is optionally sent to the server to the client. By the server to the client. The certificate request message includes a list of distinguished names of certificates that the server trusts. It tells the client, DocuSign in our case, to respond with its own certificate or with the certificate and any needed intermediate certificates. So this is what makes it TLS, or mutual TLS, is that the server doesn't just say, okay, I got you, here's your stuff. It says, let me check you out and make sure I know about you. And then it says, please send me your own creds so that we can have a mutual agreement about who we are. And that is an extra step from normal TLS. Normal TLS would not do that. It would just do the handshake and give the data back if it was kind of a private public key sort of thing. In this case, both of them sort of trust the other one at the same level. Okay, so fuck TLS. A list of distinguished names of root certificates that the server trusts. It tells the client, DocuSign in our case, to respond with its own certificate or with its certificate and all needed intermediate certificates. Yeah, the client, and this is the unusual thing, is it actually sends certs to the server on request. That does not happen in a normal TLS exchange. The client responds with a client certificate message. It includes the client certificate and needed intermediate certificates. The client, the chain to one of the distinguished names listed in the certificate request message. Okay. After sending the cert request message and receiving a reply, the server verifies the client certificate. It's like, I trust you now. When verification is successful, the server has authenticated client. So obviously, this doesn't work unless both parties are on board with the same certificate authority or authorities. So they have to say, so when they say, hey, client, are we friends here? And he's like, let me show you the stuff I got. And you're like, cool. It's like, wait, your stuff's signed by something that I don't think is real. And you're like, or no, it's just signed by the same thing that my certificates are signed. Hey, buddy, how's it going? And it's like, hey, we can be friends because you have certs, I have certs. We can communicate safely because we both trust the person, or we both trust the CA that says both of us are real. And it could be any number of CAs that do that, but usually there's the one root CA. Pay for text. No, Paul, you're getting saved for YouTube, so you might want to take it down a notch. I'm just letting you know. Favorite. Base. This part is the basis of zero trust. Yeah, and that's. I asked when because I was kind of going there. Yeah, allows you to expose the service on public net, and it will refuse to talk to anyone without a trusted client server, as long as everything's side by. This is cool because mTLS as a concept is a way of dealing with the failures of GPG to say I don't trust you. I don't know who you are. And the idea that the CA is in TLS, I think this is important to point out for beginners too. The difference between GPG and TLS is that TLS has the concept of a certificate authority built into the interactions. Yeah, and GPG doesn't have that. I mean, GPG, you have to explicitly do those kind of things. In the TLS exchange, there can be one or more CAs in the mix that everybody agrees know about who's supposed to be who, and that makes it much easier to come to some agreement about how we're going to trust each other. You did this for exposing Home Assistant to the internet so I can access from my phone remotely. But because of malicious CAs from malware, Android now permanently displays a message like you have unknown CAs in your store. I hate that. Hold on. So the client certificates allow the server to verify that the client is who they say they are on what identifier domain name IP. That's using the cert CA validation stuff. Yeah, because the client certificates have been signed by the CA. And so the person asking for those can say, because it knows the CA as well, as it says, hey, have you been signed by the same CA? And if it has been, then they know it can be trusted. Anyways, at a key exchange, they might do that. I don't know. Certificate is a claim by the client that says, I can prove that I am what I say. Yep. Common name in the X509 cert optional list of IPs. And that's why I'm getting into this, because we're about to add those things. That's the whole point of this. Yeah. If the server knows who X is and it decides X should be trusted, then it decides, yeah. Good CA, a root CA can spoof all the web traffic, yeah. Can spoof web traffic? I don't know about that one. I don't know about that specific one. Yeah. But yes, they can create a certificate that is false. Yes. Malicious search, yeah. All right, so let's get back to it. I feel like I got my head around mTLS. That was good, though. That was a good quick introduction to mutual TLS, which is just two-sided TLS. I trust you and you trust me. Normally a web request is just I trust the services. The client says I trust the server. That's it. All right. So, okay. Client certificate cube config for the scheduler to talk to the AP server. So these are all of the certs. Okay. So where certificates are stored, we already talked about that. Configure certificates manually. If you don't want kubeadm to generate required certificates, you can generate them by using a single root CA, which I want to do, or by providing all certificates. See certificates for details on creating your own certificate authority. See certificate management with kubeadm for more on managing certificates. This is hard for me because there's a part of me that actually wants to do a Letsencrypt and create my own CA that can work on the internet and have that be the thing that I use for my Kubernetes cluster. There's a conversation we could have about whether you should use an internal CA or you should use an external CA, and then that conversation is somewhat related to what are you going to do with your infrastructure. You can't get a public CA. I mean, no, but I could use a public CA. I could use a public CA like Letsencrypt as my CA, as opposed to self-signing my certs, which is I think what they do for most internal stuff. Right? Yeah. If you don't want kubeadm to generate the required certificates, you can create them by yourself. You won't be able to create the type of certs needed for Kubernetes if you use Letsencrypt because it doesn't allow you to have to change the scope and stuff. That's a good thing to know. I would not have known that. Yeah. This is interesting. I'm gonna take your word on that. But okay. CAs. So it's true to say that CAs like Letsencrypt cannot work, do not allow the type of certs needed for Kubernetes. So they're not the same thing. That's good to know. So that would mean you have step-ca.cli. I don't know what that is. So we need to set up our own CA, bottom line. And I don't know how to do that. So we're going to look into that. For whatever Kubernetes needs. Smallstep.org. Is that a CA? Is that an internal CA that you can run, or is it like an external thing, service that you can like organize your certs through? I mean, if I'm going to go 100% internal, I don't want to. What I'm wondering is if I'm ever going to run into a bottleneck. I'm wondering if I'm ever going to run into a bottleneck that stops me from using the same certificates for an internet-facing cluster, because I use my own internal CA. Sounds like that's not the issue though, because if you were exposing services to the outside world, you would probably use a Letsencrypt like certificate for the inbound access point that's getting into the Ingress conversation. So I think Ingress has its own certificates for exposing services. And so I believe what I'm hearing people say is that using an internal CA of your own management, whatever software you choose to use, is the way to go. And then if and when you need to expose any of those services to the internet, you can use an Ingress for that. And at the time, you'll set up an internet-facing certificate. So, these certificates set up for TLS client use. Yeah. Same protocol as Letsencrypt. Yes, absolutely. Supports Acme, so you can run your own automated cert enrollment. Wow, that's cool. Okay. How do I install Kubernetes on my own private virtual server? We've been doing that for the last month, Jim. So you're in the right place, but that's what this is, right? I have a 30 node physical node cluster over here that we're working on. Yeah, but we are like really far in. You can go back and watch all the videos, hours and hours and hours of videos. And I am writing a summary of it if you want to go to my home lab, rwxrob/homelab on GitHub. And I do write a log of all the, drama and changes in direction. Yeah. So /37, that's in my home. No, I didn't. We spent like 3 hours trying to decide how to subnet my house. And we ended up I got an OpenSense router, OpenSense gateway, and then I ended up doing 192.168/16. Up to that point, honestly, I thought there was only /24. I did not know there was a /16. And TLS doesn't suck. It's the basis of safe, secure communications on the internet today. Some vodka drinking and rats, absolutely. No bare nipples, though. No. So subnet would be like 2 IPs. This is TLS. I had a /22 subnet for a while, but that made VLANs instead. I went back to 24s. Yeah. Part of the problem is I don't know how many IPs I'm going to need for different things. It sucks, but it's the best we got. It's true. If you don't want kubeadm to generate the required certificates, you can use them. We talked about that. Single root CA. You can create a single root CA controlled by an administrator. Before I go diving down the rabbit hole to look at some of the PKI providers like Small Step, I want to make sure of my options. So let's keep reading. You want to learn that? Yeah, I've been trying to learn it. One public IP or whatever, but there's 3 private ranges you can use. Well, yeah. Yeah, the A and the C and the D. Yeah, I don't know. We're fine. I decided I'm only going to have 2 networks. If I ever get problems, it's going to be because I'm going to run 2 clusters. But I think I'll be fine. I think it'll be fine because the nodes are defined by the external Etsy host stuff for communication. So I'm not going to run out of I'm not going to run out of stuff. All the rest of the internal Kubernetes virtual IP stuff is all managed internally. So I don't and then we also concluded that the pod container cider is just for the networking environments in a single container runtime on a single node. So there's no chance of them conflicting with other stuff unless you're going to try to do something with the container runtime on that node instead of Kubernetes, which is a huge mistake. So I feel like we've got a handle on that. Let's keep going. So you can create a single root CA controlled by administrator to internet facing services will have own certs with Ingress. All right, so that's good to know. That sets my mind at ease. And okay, so it was a securely held private and public key pair. Yeah. At the end of the day, that's all it is. And then you have to decide where to put it, right? And that's the decisions we're making. We have 1 minute left of this Pomo break, and then we'll be listening to some music for about 8 minutes, and we'll actually probably start making some certs. I mean, there's a lot of ways to do this. I could just use Kubernetes to make the certs and then copy them out, right? But I would rather not like to do that. The Hacker Yoga music or the Devil music? You want my Devil music? Devil's okay. We'll do the Devil's music. You're using public IPs, and you're home with your NAT. You can't talk to Cloud anymore. Well, that would be a learning opportunity. So, okay. So all certificates. If you don't wish to copy the CA private keys in your cluster, you can generate all certificates yourself. The host sans. This actually, when in the hardway, Kelsey Grammer hardway stuff, this stuff is actually covered in the hardway stuff, so that is still relevant. Not Kelsey Grammer, Hightower. wrong Kelsey. It's not Fraser. Fraser does Kubernetes. No, God. Kelsey's Grammer's daughter is hot. Did I say that? Anyway, so Kelsey, hard way. So this is the hard way. This thing is, before you go running off and doing this thing, please understand that this is largely completely irrelevant information in 2022. So, but the reason we're here is because I remember there being stuff about doing certs, and I'm trying to see if he's doing the certs using openssl or CLLS or whatever the other tool is. OpenSSL is the one I'm going to use. But I mean, the reason this is so out of date is they actually don't run anything in pods even. They have like the kube proxy and everything. They're running as system D services, which you can do, but that's so dated. That's no longer relevant at all. But I mean, it's just trying to make the point. I mean, the old days you had to do this. You had to set up all these things. So, What I'm trying to find though is the cert stuff. And I don't know where it is, so I'm going to search. Wait, what? That is not where we want to be. Here, Google Cloud Platform. Let's go search for certs. Embed certs equals true. Client certificate. See all this stuff right here? Set cluster Kubernetes the hard way. This, you don't have to do any of this stuff anymore. No. No, you don't. TypeScript Pros, not in this chat. I mean, maybe. Some people come wandering here. Kubelet Kubernetes configuration file. We don't need that. Generate TLS certificates. Here we go. So, providing a CA and generating TLS certificates. This is, I think this is one part of the Kelsey Hightower tutorial stuff that actually still applies. So, now it does say to use Cloudflare's kit. I am not using anything from Cloudflare. That's all I'm going to say about that. Not using anything from Cloudflare. Never using anything from Cloudflare. Famous last words, right? I don't like Cloudflare at all. I don't. There are lots of reasons. I want to use the openssl tool because it's the only tool I have. Right? And by the way, openssl is I believe that's on the test. You have to know openssl. Open is the old hammered bad way of doing it, right? Proxy client certificate, the scheduler client certificate. So the reason I do like this page is that it goes through that list of certificates that we were like belaboring over when we were like, drawing lines on the components page. And it does go over all of them. So you have the cert authority, which is, it's not even one of the ones listed, right? I went through it, but it was just copy and paste like a sequence of 8 commands for a million search results. Oh boy. In this section, you'll provision a certificate authority that can be used to generate additional TLS certificates. Yes. This is the key pair. This is the CA key pair that Mindseye and others were talking about. You have to create that so that it can be used to sign everything. That is the one that you print out on paper and then delete or put someplace that, is really secure. I guess it can't be deleted because you have to validate that it's been, but you have to be really, really, really careful with the private CA. You couldn't do anything if you print it on paper, but you'd want to do that. Just put it in my secure backups folder on GitHub. The key has to be accessible. I know. I forgot about that. But it's like the most important thing to protect, period. So client and server, I mean, you would violate your entire CA. It would take, if you use hash backup with client-side encrypts, data backup before backing them up. There's also a thing called, do you guys know about sealed secrets? They're super cool. Sealed secrets is a way to save hashes in GitHub that refer to secrets so that you can actually save source code with secrets in it and not have to do any extra configuration. And then when you use something with a sealed secret, it looks it up and replaces it at that point. At the Git level. It's pretty cool. All certs, you can put the CA private key away. After you generate all the certs, you can put the CA private key away. I think the private, by away, I think you mean separate on like air gapped from everything else, right? Who was sold up boring it. Teach us outdated IP classes A, B, and C, and D that don't exist anymore. They're have mercy on those people that are in academia, man. They just can't keep up. They can't keep up. It's not that they don't want to. They're so embroiled in school politics, and I'm gonna air gap the CA cert. Yeah, I might even print it on paper and never. Have you seen that you can do now? Have you seen the stuff you can do with QR codes now? It's pretty damn awesome. Yeah, you can print a physical copy of anything as a QR code, and not even referring to something else, because it depends on how much data is in it. But you can QR code something, and then you can just scan that shit, and then there's no digital copy of that thing except for the QR code. And obviously then you would put that in a safety deposit box or something like. I mean, if you really want to do this right, that's the kind of thing you would do. You backed up all your 2FA with a QR. Yeah. I mean, you know what's funny about this is that by setting up the CA and a home lab, I think this might be fun. By setting up an actual CA on my home lab, I may have just set up my entire home encryption model that doesn't have to depend on GPG. I mean, I could, right? But why? I could develop different systems that depend on it. What if the paper gets wet and dry and QR gets blurry? Well, make sure you have another one somewhere. You have to have another Horcrux somewhere. You have to store one part of the Horcrux over here and then another part over there. So that may actually be the name of my CA. It may or may not be called Horcrux. What you could do is you could have a CA that signs the other CA that signs the other CA. You could have like 7 CAs that sign each other, and that could be your Horcrux. If you want this kind of security to your employees, it needs to be simplified so everyone doesn't get a heart attack. Yeah, that's true. Every party in the hack of the century. Such a pain. It's true. I tried 12 hours, scan a QR, decode the base 64 to a file, remember what kind of file it was, and then remember my password. Yeah. Intermediate CAs. Yes, right. Yeah. It is. Cut the QR code into squares. Yeah, why not? You can totally do that. Fuck, I might actually do that. Yeah, find Gringotts, put one of the squares in that Gringotts. Oh, by the way, laminate it, right? Make sure you laminate it so it doesn't get eaten by rats or something. And then put that piece in Gringotts, and then go. I might actually do that. That would just be really fun. I mean, right now, most of the time, I'm okay with a raw Git repo. You guys know how to do raw Git repos? Do you guys know how to do raw Git repos? If you're good, you can actually, if you're really good, you can put a raw Git repo on a physical token on a, like a YubiKey. And now you've got a raw Git repo that's got all of your data on it, and you have the method of authenticating to the thing, and it's all physical. I mean, it has to be in your possession. I've done this so many times. I haven't had it in my possession. I can't access my Disney Plus password or whatever, because, all they need is a $5 wrench. Yeah, give me your thing. Not if you eat it, then they'd have to kill you. And not if it's a Gringotts. That's why you never have it in your possession. You have to put it somewhere else. Yeah. Or you do you do that thing where you give it to all your friends and say, hide these for me. I don't want you to tell me where they are. And then you have to have all those people there's like a whole bunch of things like that, but jigsaw puzzle QR cert. I may actually make one of those because that just sounds so stinking cool. Put 64 password slot could work too. Yeah. Yeah. The YubiKey plain 64 character password slot. That's the one that I would probably use. Yeah. Encrypt your CA using stenography and a wall painting. That just makes it fun. Or you could hide it in some kind of you could make have you ever seen when they do a sound? They'll make sounds that if you run them through a sound analysis tool will actually have values in there. And then you do the whole contact thing. It's like, oh, there's an offset carrier here. I'm hearing something. There's an offset carrier here. There's more here. There's a lot more data here. There's a lot more data here than it's letting on. If you haven't seen Contact, go watch it right now. YubiKeys for backups. I don't know if you can clone YubiKeys. Can you do that, Mossy? That's the bad part about YubiKeys is if they go bad, you're screwed. right? I mean, you can buy like 3 at a time for like $400 or something. It's ridiculous. NFC chip and let it craft into your calculator. Ooh, I like that. I may or may not have hidden really critical password information in a photo that's available all over the place at one time. I don't do that anymore, so don't worry. You can probably guess the photo. Yeah. That was really fun, by the way. Nobody knew. I'm giving up my secret now, but nobody knew. Nobody knew that one of the most public pieces of my personality had one of the most private keys in it for all that time. And there's no way they could have found it because it was all personally made. There's no way they would have found it. That was really fun. That's a fun project. Yeah, to hide a secret in something. Yeah. So, yeah. 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 I'm not going to say anything more about that. You may, or CRISPR, oh my God, that would be the best of all. Oh my God, you win the prize. We're having a break here, obviously. We're going to put hacker music on because this is so fun. That you win the prize. That would be by far the coolest of all. People do that shit. Wait, YouTube. I'm sorry, YouTube. We have to go away. All right, YouTube, you're back. We had fun. We listened to our music. We talked about distros. We complained about all kinds of fun things. And don't say our root passwords in chat. YouTube will, come after you. So we're going to do another 58 minutes here. We're going to keep going until we get some actual certs created. That is my goal for the day. We do keep getting distracted by rabbit holes, but I think they're relevant rabbit holes for the most part. Not always, but we're going to do that. So let's, try Linux at a VM. Good idea. Or BSD for that matter. Back to our certs page. So as when we last left, we came out to Kelsey Hightower's tutorial, which has been cited often by a lot of people, and I usually have to pull people back from and tell them, look, it's not modern. But this particular part about creating certificate authorities is actually very relevant. And even though it uses a tool that I'm going to choose to avoid. I should probably close my door. I think my stepson might be annoyed. Just a sec. All right. So, I mean, this does give you a lot of, ideas about creating a cert. What are the properties of a cert and a bunch of stuff like that. And I have no idea. So we've got several resources to go to here. Let's finish down the path here. So configure certs manually. Certificate management with kubeadm. See certificates for users on creating your own certificate authority. So that is going to be our source of truth. We're going to come back to this link in just a second. I do want to kind of read the rest of this page because as I've found out, oftentimes critical stuff is after where you would expect it to be in the documentation. The single root CA. You can create a single root CA and then make a QR code of it, split it up, and save them as Horcruxes all throughout the world. If you want to. We had some fun talking about that before we left. Controlled by an administrator. The CA after you make all your certs is really important. Always everything before you follow along. Yeah, this root CA can then create multiple intermediate CAs and delegate all for the creation of Kubernetes itself. And then you can get rid of it. Actually, I mean, you want to get totally rid of it, but you can get it off of your system. That's why, once again, the reason we're considering this is because the most secure way to deal with certificates is to do your own. As long as you do it right, and then to move that certificate authority, which is just a pub key prayer, off of the system completely. And then nobody can emulate and nobody can pretend that they're you after that. They might be able to pretend they're a component, a piece of your infrastructure, but they can't pretend they can't make up their own things, and that's the whole goal here. It's also a big part of zero trust architecture. So I actually might even use the CA, as I said before, to do other things, to secure other things in my life that I don't, instead of GPG perhaps, because it's slightly simpler than GPG, but we'll get to that. This root CA can then create multiple intermediate CAs and delegate all further creation to Kubernetes itself. Pass CA. So required CAs, the default CA CN is Kubernetes-CA etcd-CA. Description, Kubernetes general CA. So apparently you have to create CAs for specific things. etcd needs a CA, you need a Kubernetes CA, and you need a Kubernetes front proxy CA if you use a front-end proxy, which I don't plan on using, but maybe worth doing anyway, for all etcd related functions. On top of the above CAs, it is also necessary to get a public-private key pair for service account management. Yes, and service accounts are how you set up proper users in the cluster. So I'm taking note of that. So on top of the above CAs, normally when you want to set up Kubernetes users, you set up service accounts and you with a specific namespace, and you somehow tie that to an ID within the system, and then you set up OAuth for tokens and stuff like that and store that internally. That is a long ways off, but that is a big piece of setting up Kubernetes on-prem for end users, is setting up actual accounts. You can, yeah, we're getting ahead of myself, but you can actually set up the one of the certificates that they said you can use is an administrator certificate, and that would just be the people administrating the server. But that's useless for you if you have people who want to use your cluster and deploy to it. They need to have a way to do that, and basically the equivalent of that is a service account. So that's what a service account is. On top of the CA, it's also necessary to get a public-private key pair for service account management, say SA key, SA pub. So this is a CA that would be responsible for signing service accounts and giving them their own pairs. The following example illustrates the CA key and certificate shown in the previous table. Kubernetes PKI CA cert, that's the high level for all of Kubernetes. The etcd one, which is separate. And I'm understanding a lot more about etcd right now. I was actually, I wish I could show you the backup code for etcd. It has arguments pointing to the certs in it. Look at the front-end proxy page after. It's not what you think. Okay, well, it said it was optional. So the following example illustrates the CA key and certificate files shown in the previous table. Front-end proxy. Let's see what that is. Configure the aggregation layer. Allows Kubernetes API server to be extended with additional APIs. Oh, yeah, this is the thing that allows us to extend the API, which are not a part of the core Kubernetes APIs. You need to have a Kubernetes cluster and aggregation layer. Is that in addition to the data layer and the control plane layer? It sounds like there's 3 layers now. All right, I didn't know that. Unlike CRDs, I was going to say if it was for CRDs, it's not. Unlike CRDs, an aggregation API involves another server, your extension API server, in addition to the standard Kubernetes API server. So it's not a CRD. It's like you're extending Kubernetes itself. Interesting. The Kubernetes API server will need to communicate with your extension API server, and your extension API server will need to communicate with the Kubernetes API server. So that would be another component here. There would be another component here called your extension server or something. And then you would need something to talk to that. Authentication flow, communicate with your extension server. Kubernetes API server uses X59 certs, just like everything else. I mean, it stands to reason that the extension server would just be like any other thing talking to the API server. It would have to have its own mTLS kind of certs. Operators and company. Yeah, but custom resource definition, those are operators. Sounds like an API extension is bigger than an operator, right? I don't know that that's true, but this seldom describes how the authentication. Yeah, we don't really need to read that. Kube API server aggregator API server. So the aggregated API server, this has got to be the extension-y kind of thing, right? All right, so we'll come back to that. It's not essential at the moment, but okay. So all certificates. If you don't wish to copy the CA private keys to your cluster, you can generate all the certificates yourself. If you don't wish to copy the CA private keys to your cluster, you can generate the certs yourself. This would mean that your CA private keys don't ever touch your cluster anywhere. That means they wouldn't even be available to the cluster. You would just get all the certs, put them in there, and your private keys would go. You'd save them off someplace else nice and safe. Equals cluster can request assigned certs that it wants and needs. When would you need a cluster to assign its own certs? This certs and configure them for the ports. Yeah, the cluster only gets the intermediates. That's much safer. See, I'm getting a handle on the security of this. Yeah. And you can have the cluster auto-rotate certs, etc. Yeah. But the management of certs is happening very externally to the cluster. It's like it's a process that has to be managed completely independently. Het, how are you doing? You can come laugh at me trying to do certs. Welcome to the Het Tanis, otherwise known as Scott the Great. Who probably does this kind of stuff in his sleep. Not me. Het is a very seasoned enterprise architect and engineer. And who has a lot more experience on the operations side than I do. We'd probably be a good team because I have a lot of coding experience and I have, not as much operations experience, which is why I don't know how to do certs. And I have a question for you. What are you an openssl cert person, or are you using the Cloudflare one? Because I'm wanting to like suffer through openssl instead of I know you can use kubeadm cert for that, but we're not going to do that. We're going to manage a private CA or 5. Here's openssl. I figured. Yeah, nice and boring and stable and mature and harder to do. And not Cloudflare. Okay, I'm just curious. Yeah. We had some good conversation about SC Linux versus AppArmor yesterday. And the conclusion was from TinyFlaw that Ubuntu Server Pro actually fulfills all of the government requirements for security. So yeah. Yeah, there's been some talk about charm date kits as well to try to make it easier to install. Anyway, so we need etcd. We need a parent CA, etcd CA, and then the default CN, etcd peer. I'm getting my handle on this. The kind server client, server client, server comma client. That would make it an mTLS possible cert. M stands for mutual TLS, which we learned earlier today is just the server requesting. When the server has a client request, it says, hey, I know you're a client and all, but do you happen to also be a server so that we can trust each other? And then it says, yes, and here's my cert. Hey, we were signed by the same CA. Let's be friends. And then it interacts at a peer level as opposed to just a one-way request like you'd have in a web browser. That's what mutual TLS is. I just learned that, so that's why I'm restating it, because it's a way to solidify it in my brain. Host names, host IPs, localhost. So yeah, kubeetcd peer, etcd health check client. These are all the individual certs needed that are going to be signed by the parent. So these, I guess, are called intermediate certs. Did I get that right? Intermediate certs are the ones that are not literally a CA. They've been signed by a CA. So these are intermediate certs, and you can have these are not intermediate certs. Can you have? You're thinking of intermediate CAs. Can you have a CA that signs another CA and then that CA signs certs? Would that be intermediate CAs? It sounds like yes. Right? So tell me something. Why can't I do that here? Why can't I make the Kubernetes CA and the etcd CA and this? Why can't I make these intermediate CAs and then have a single master CA that signs these intermediate CAs? Is that doable? And then I would have one CA to rule them all. It sounds like yeah, but it doesn't appear that way here. Is that I could do that, right? Yeah. Yeah, there's going to be a lot of on-prem domination happening. It's going to be interesting. Set up the on-prem cluster without having to spend 3 weeks doing it. Well, I'm brand new, so I plan on getting faster than 3 weeks, but it does take a while, yeah. Does it say so in the first paragraph? It says you can create a single root CA controlled by an administrator. This root CA can then create multiple... I mean, I read that, but it didn't process. All right. I want a picture of this. I am going to write an Excalibur picture. Come help me out. There's etcd. I want to make a picture. This is my other picture from my nodes and my control planes. I am going to make a picture so I can learn it. Tawny fought to save the day. You're going to laugh at us. I feel like I'm making progress, but sometimes I don't know. Reset the canvas, yes. Are you sure? Yes. Your audio's not working yet. I'm so sorry. Here we go. So, what thing should be a cert? How about a square? I have a square. There's my square. There's a cert. There's a cert. See, I told you it's a cert. Insert image. Do you have any images? No, that's fine. What's that? All right, so here is a cert. How do we make it look like a cert? Should we make it look like a fancy cert? Actually, I can import graphics. Save as an image. I know. Bike shedding. I know. Just give me a sec to do it. Got it to work now. I was fighting my laptop for audio. Yeah. How do I make it look like a cert? Should I just draw on it? How about this? How about I just go... CRT maybe? Okay, fine. These are very important decisions. Add a stamp. Ooh, yeah. I don't know where a stamp is. The kubeadm can take time. And you also must integrate it with the rest of the company's infrastructure. Yes. There's going to be more turn. This is why OpenShift is so popular. I'm not going to lie. I don't like it. I don't want to use it. But look, doing it, the same reason that Kelsey Hightower's The Hightower was so successful, I mean, the hard way, was so successful, is the same reason going through this pain and suffering for 3 weeks is still worth it. Because even though we have kubeadm to help us out, and Kelsey didn't, this is extremely educational. And so then when you go to OpenShift and you go, oh, they're just using their own CA or they're doing, I mean, you know what it's doing. Is it using a stack etcd? What does it even mean, right? You can talk about all the other on-prem solutions, the turnkey solutions, from a position of authority because you understand how it works because you set it up the hard way, or the modern hard way, we'll say, the kubeadm way. And so I find this extremely valuable. Also Broadcom, yeah, I know. Version of OpenShift. Anyway, so there we go. We got a cert, right? Don't they end with .pem? What do they end with? I'm getting ahead of myself. So this is a CA. I'm just gonna do it. I don't want to overthink this. See, so you have a CA, like you have the CA to rule them all, and the real fund starts with expiration and rotation. Yes, it does, and that's where people do the one that's managed internally. They don't do this crap. right? So you have a main CA. So I mean, this is like the gold one. This is let's make a gold. Oh my gosh, that was not what I wanted. How do I find gold? I want gold. I want gold. Gold. Okay, I mean that's not gold, but whatever. So, I mean, how about red? Red. What's with all the palette? The like soft colors. How about pink? Oh, white. So sorry. 30K to start. Oh my god. So you got that right, and then you have these like. I kind of want to make this one red. You know what? You can yell at me for bike shedding. I don't care. RGB. So we'll do this. We'll do FF. No, we'll do FF0000. How about R? What? I guess that must be red. It must be getting rendered weird. Oh well. I guess that's red. I don't know. I'm not thinking about that anymore. Okay, so intermediate certs. Make work program. I'm not gonna lie. It really is. It definitely is. So we have this one, and then hey, let's draw arrows. Arrow. I mean, it goes without saying, but I just want to visualize it. So, and we'll figure out what the name of it and everything. And then these guys make, I think it's dark mode shenanigans. I think you're right. I do. Excalibur turned off though. So it was, yeah, it's definitely dark mode. Anyway, so, and then what? Then we have these other things. Actually, what happened? What did I do? Oh, there you are. Can we make them smaller? Okay, so they're smaller. They're not as big in scope, so we'll make them smaller. And then you have the really tiny ones, which are the actual certs themselves. And I kind of want to do a different thing here, but I don't know. We could just make it green. Green. How about that? And it's not a CA anymore, right? Now these are called CN. Root CA R signs vouchers for intermediate CA I signs a cert C without a revolvement of R. What are the letters for that? You know what I mean? Wrong thing. CN is a field property of a certificate common name. Okay, so that's the common name. So those are CAs. I mean, that's just an acronym. And then we have the path, the default CN, required CAs, and the path ca.crt. So we'll say CRT. How about that? I mean, it is a cert, but would it be PEM or would it be cert? It's not a property of the cert. Absolutely not. This is just, you're right. I get you. It's not a property. That could be an easy thing to confuse. Okay, so this is not a CA. And inspect them with openssl command. We're going to do that. Yeah, we're going to definitely do that right now. I just want to be sure of the organization. And as I understand it, this can be screwed up pretty easily. So let's call this a CRT, and I'll make it lowercase on purpose. All right, so we have, one or more certs. That's very small. I don't know if that's gonna work. We'll make this bigger. How about that? All right, so, and then you have, okay. And then you have CSS cert. So it's pretty basic stuff. I want it to look nice and easy to understand because it kind of is, right? And then over here we have a different color set of certs. Maybe we'll make this one pink or purple. And we'll make that the same color. You know what I'm saying? The flag is the flag is called isCA. Hey, how are you? And we'll do green over here. Greenish. All right, so then over here we'll have like another one. Signed by your CSW sitter, signed, self-signed. I don't think so. I don't think any of this is self-signed. I think that's why we're doing this way. C4, lol. It's not. It's actually CA. You can't read it though because it's being all fancy in the type. Here, let's make it bigger so you can see it though. Yeah, it is kind of small. I will give you that. Okay, so we need another color. I'm about orange. I like orange. Okay, so we're gonna copy these, and these. I mean, we'll put some other names on here, so we can know what we're dealing with here. Your own CA is self-signed in terms of public net. Yes. So this the only thing that's self-signed is the top. Correct. The only thing that's self-signed is the top CA, the root CA. It's a pretty fun website. It is. So yeah, and then more arrows. We can never have too many arrows. Yeah, I need to just change to the arrow tool, and then life will be good. Arrow tool number 5. Wait, that was a mistake. Where's my 5? CA. Happy little arrows. I mean, it's. I know it's obvious to everyone else, but it's pretty and it makes me happy. Okay, so yes, I am Hayden. I think you're the one who told us about it. I finally figured out how to save stuff. The trick with this is you have to save it locally. Otherwise, you think you need to get an account. You actually don't need to. Happy little arrows. Indeed. So this is the root CA. Is that fair to say? This is the one where after you do some signing, you want to like hide it and away from the world, and not use it again unless you have to. Just makes it easier life if you have different devices. Like, yeah, I do not have different devices for this particular thing. So these are called intermediate CAs. So I'm gonna put some words here. Yeah, I'm gonna say, wait, what? What is text 8? So we'll say intermediate CAs. Intermediate CAs. That's what these are. I don't like you. I don't like you. I want you to be more compliant here. I actually care. Hey, I didn't know you could attach them. Yeah, my boxes are attached. I did not know that. It attaches boxes. That's cool. I did not know that. That is so cool. That is really freaking cool. You can go down here. You can go down here too. You can kind of go over here. How about that? And you can kind of go over here. I know I'm being pedantic. Okay. So intermediate CAs. Just double click. Oh, really? Did not know that. So then we have the root CA, intermediate CAs. I could probably get rid of this word root here. Yeah, and do it like this, and we'll double click root CA. Yeah, so this is like the root, intermediate CAs, the root CA. We'll probably put a line here. Put a line. If we do a dotted line, I would make it a dotted line. Let's make another one, or just copy this one. Put this one down here. We have intermediate CAs, the root CA, and yeah, I guess you could get pretty crazy with this if you really wanted to. And then down here, we could do, I mean, this is the actual certs, right? So here's the actual certs. Actual certificates. Certificate pairs. And really, if you know about the public key thing, it's really only important that you have the private one. You can always generate the public one from the private one, but you can't do the reverse. So this is why like password managers only ask for the private cert, because they can derive the public cert from it. So you have some people say pair, but you really don't need a pair, right? You really don't need it. Say so for production environment. Yeah. Let's see. TLS endpoints will need to present the intermediate certs as well as their own leaf certs during connection setup. Really? Why? Certificates suck to manage, and I don't envy you. Okay, thank you. Don't have a choice. You can't generate the cert from the private key. You can't? You can do that with GPG. You can use the CA just... Oh, because it has to be signed. I see. Yeah. Yeah, that makes sense. I mean, you can't sign a thing that hasn't been derived from the other thing. So what you're saying is that when you're talking SSL or TLS, you're talking about signing the public and private cert with the CA. It contains a lot more data from the public key. Okay, gotcha. So we should probably say cert pair here. I wish I could make these pictures better, but I can't. Why is it doing that? Okay. So there's kind of two of them there. Yeah, it's like a pair. I think that's not going to work. We'll just call it a cert. There's actually two of them, though. Every time you see cert, there's two. So you could have multiple levels of CA, whatever. Intermediate cert, it's the thing that proves that Google trusts Rob. So if you do an intermediate thing, you also have to have the intermediate. I wonder if Kubernetes knows about that. How does it know about all the certs? If you do an intermediate layer like this is interesting. It's going to be interesting to see how this works. Yeah. You may optionally omit the root based on the spec. Let's not get into ourselves in chat. Well, we're kind of... All right, so here we are on this certs thing. And here's our PKI thing. So we have a bunch of certs we have to make. The default CN is Kubernetes CA. So that would be... This is the default certificate name would be Kubernetes CA. Which we're going to use the names that are generated, that are expected by Kubernetes, because then we won't have to redo things. So we'd have to go look at this every time. And then these are all signed by a top level. Let's see. On top of the above CAs, it is also necessary to provide a public key pair for the service account manager. We talked about that. SA pub. The following example is going to CA. I don't see SA key here. The CA key and service. I wonder who signs that one. Sending the root is wasted bandwidth. It's also insecure. You need to walk up the cert tree. Yeah. Okay. All certificates. If you don't wish to copy the CA private keys to your cluster, you can generate all certificates yourself. That's what we're going to do. From leaf to the root for trust for validation. No, you don't. You don't need root. That's what everyone's been saying. If it's wrong, we'll find out. I hope that we don't have to have the root on there. I hope that we can have the root safely tucked away in another system. I mean, that's the point, right? But we'll see. But what y'all are saying is you can't get away with just putting your certs on there. You have to put the certs and the CA certs to go with it. All the intermediate ones have to be there as well. The checking peer need the cert CA cert. Yeah. The root private key with the root cert. Don't confuse the root private key with the root cert. All right, help me out with that one. So you need to be able to construct the whole chain. So you need the root public cert installed already, but not the private key for the cert. The cert can be on there. The key you need to hide. So this is the root certificate authority cert, but it has a private key, you're saying. Trust anchors, but we won't get into that now. Okay. So you're saying that there is another thing here. There's a key that enables the private cert, right? So the private key, which is kind of implied as a part of this thing, because it is a cert, it's got a public and private component to it. So what you're saying is you can put away the that this can be, like locked off somewhere. This does not need to be like, whatever. I mean, it can be kind of be like cordoned off, right? You need the key to make new intermediate CAs when you make them. Otherwise, you don't need it, right? So this can go someplace else, if that makes sense. And this is kind of like, I think this should be like secure location or offsite or someplace like that, right? So the private key from the CA goes someplace else. That's how you stay safe. Everything else, if they get it, they can impersonate that thing or the things that are managed under that CA, but they don't get access to everything to like make their own or to override these other ones, I'm guessing. So you got root pairs, certificate asserting trust, intermediate pairs. So there's actually so this, let's say this is the private key, but so this is the cert. This is a CA cert, and these are also certs, right? So this is different because this is a CA cert, right? I mean, it is a cert. It's just the private part of it is not there. Come on, where are you? So did I get that right? I have an associated private key. I keep forgetting that the cert is the public key in the private public key pair. That's what I keep forgetting. I keep making the mistake that a cert is the combination of the private and public key pair. It is not. The cert is, and I'm going to actually add a little note here. This will help me understand it because I know public-private key pairs from SSH and GPG. Pub key. And that will help me understand. I mean, obviously the certificates are doing more with everything in there, but I think that'll help me understand it better. Separate from the signed certificate. Yeah, so the public key is saved with other data inside of the certificate. That's what the CN is and all that stuff. And that stuff is all saved in the certificate. And the private key that's associated with the whole, pub key, pub private key kind of combination thing, which is a part of the core idea of asymmetric encryption, is someplace else. It's in another file. Does the file have metadata in it? Or is it more like a GPG thing where it's just the key? I mean, I'm sure we're going to make an experiment with this, but I'm just curious. I suspect it's got some sort of metadata. I feel like that this whole certificate thing is largely defined and distinguished from other forms of public-private key utilization by the encapsulation of metadata with the keys. That seems to be, to me, one of the main distinction. The key is just a key. You can kind of put it in context if you want. So So if you're coming at this and you know SSH and you know GPG, you know that GPG has a limited amount of metadata that travel with the key pair. In SSH, there is no metadata that travels with the key pair. It's just a key. And when we're talking about certificates, we're now talking about keys that are, at least the public key, is associated specifically with very important metadata that identifies domain, scope, and IPs, among other things. Now, I think it's safe to say that this whole certificate stuff has grown. I mean, it started out as a way to authenticate, domains and IP numbers on the web, and it's kind of grown to allow metadata that allows it to be associated with other forms of communication and other things. And I would guess that's what's behind zero trust. A lot of the zero trust implementation of certs, because there's got to be other ways to identify an association to a thing besides just a domain. Maybe not, though. Maybe it's only through the domain. Okay, so we're going to go figure that out. Again, it's a pub key plus metadata. Did I get that right? So we're going to put that down here. Okay, so yeah, we're going to do that. We're going to go look at all the certs right now. So we're just about ready to dive into starting to create a bunch of certs and then just really dig into them and look at them and see what the properties are and get our hands dirty. You can do SMIME and code signing, really. So, I mean, I know 509 is ancient. I remember doing it in 94, 96, something like that. All right, so let's do that. So I feel like one of the things that I was struggling with before we get into the guts of making a cert, I just want to recap. One of the things that I really struggled with certificates was the association of the CAs to the actual certs and where the keys lived and where the data was. And I feel like I have a real solid handle on that now. So now we're going to confirm that understanding by going in there and making a whole bunch of certs and seeing if my understanding is correct on this. But this hierarchical relationship is things that people fuck up all the time. They fuck this up all the time. In fact, I can tell you, I probably shouldn't, but I can tell you that we have incorrectly set up our intermediate certs in some of our systems. And the naming that's in them is totally messed up. And they've used wildcards in order to make up for it. There's lots of problems. And so I do feel like, and I keep staring at this because I want it to come to my brain every time I'm thinking about certificates. This pub key metadata thing is really big for me. Somebody telling me, hey, there's no private key in there, and that was a big thing. So let's do that. So let's take a recap, and then we'll jump in with the rest of the 16 minutes on this POMO. So, I mean, if there's one thing you don't want to mess up, it's your certs. It's just not something you want to really not understand and just half-ass it. It's a really bad idea. People do all the time though. Stuff for intermediates that is sadly mostly unused. Yes. Yeah. They're like, oh, I need to see it. And to tell you the truth, I didn't really understand intermediates till just now. I finally kind of broke through, and so, I mean, I conceptually, I had no idea that they even existed. I knew there was a hierarchy by the way people would talk about it, but I did not understand the association with the root CA, and that makes it a lot clearer for me. Thank you for all your help, by the way. So yeah, we were just saying created. I wish I could share this with others. I don't think I can. I'm gonna have to make a picture or something. I mean, I can do that later. I do want to save it, though, before I forget. Save as image, no. Export. Export to disk. Save to file. I have a bunch of stuff in here. Let's call it TLS cert organization. Save. Can you get a shareable link? Oh, you can? A shareable link. Export as a read-only link. All right. There you go. Now you have one. Oh my God, that is a huge link. I reached the maximum characters. Okay, that was not it. Did you see how big this is? I mean, I have to put that through some sort of like... Maybe not. I don't know. Maybe I did it wrong. I might have done it wrong. Here, try that one. It's not going to link because it's dumb. It's stupid. Put everything in the hash. Yeah, that's not cool. I mean, I can put it here. I kind of want to do something better with it, but whatever. Use a base 64 hash. Why does that mean that it's now writable? It says it's read-only link, so it works. Nice. Maybe you can like copy it or something and mess with your own. Very cool. All right, so created visual of cert /CA relationship and talked through organization. And okay, now we're going to make them. So we have 13 minutes to start making them. It's a browser only link. Nice. See, it has a hashtag. Oh, that's right. That's not sensor. Okay, that's client based. Yeah. So now it's time to actually play, and I know we've been waiting a long time to do that, but I feel like I'm ready. So when I see artifacts, I can kind of place them on this map wherever they go, and we can go for it. So I think TinyFile has written the exact openssl command. Tanis confirms that is their favorite tool. We will not be using CFSSL. Cloudflare can jump in the lake. I am not a Cloudflare fan at all. So, and we're going to just keep moving on here. How about what did it do to the internet? How about taking the internet all down for more than a day, more than once, because of fat-fingered shit on the DNS servers? Centralization of DNS services and everything through Cloudflare is a distinct anti-pattern in direct contrast to the creation and purpose of the internet. And I refuse to participate. For what? To get maybe a few milliseconds of optimization because you're on a CDN? No, not in my world. It's not the world I want to live in. If you want to live in that world, fine. Plus, most of their back-end shit is all in TypeScript. So I got to follow for that. Thank you. I don't want to live in that world. If you want to live in that world, fine. So anyway, there's great. I'm not attacking engineers. There's great engineers over there, but the very premise of Cloudflare is just busted, really bad. And then I tried to use it. How many times have you tried to go to a site that's been blocked by Cloudflare stuff and you're sitting around forever waiting for authentication that you're a real person? Why? So that people can prevent denial of service attacks? And then they say that it's completely antithetical to their whole point of existence, which is supposed to be CDN, speed, like Akamai kind of speed. And now you have to sit through a Cloudflare authentication. You can't even get to the website. So instead of having like that ultra golden like load time, like time to load, is now been put off by the fact that your website, the person on the website has decided they're so scared that they got to prevent DDoS attacks, and so they've completely negated the very purpose of a CDN in the first place. It's so architecturally unsound and stupid. I don't want anything to do with it. There. Okay, I'm done. Oh, I don't know. All right, we're back to more productive things. But somebody asked and I had to give it to you. So I gave it to you for free. There's my opinion for free. Like, is that true though? Yeah. Not the 7Ls. All right, all right. What have I started? What have I started? Somebody can clip it or whatever, but this is all getting saved for YouTube. It's like, yeah, everybody just keeps running right off the cliff, the Cloudflare cliff, and I am not going to promote that. I'm not going to do it. Strangely enough, I actually tried to use them for a DNS provider, and it was so stinking slow. I said, screw that. And I actually went with Google instead until I can set up my own core DNS internally, internal non-unbound DNS server. And I do plan to do that internally eventually. I'm not there yet. Right now, I'm just a bunch of host files, which surprisingly are much more efficient and beneficial for a home lab because you get SSH tab completion and things like that you do not get with a DNS server. So believe it or not, there's actually an advantage to a home lab person to use an Etsy host file managed through Ansible over a core DNS server or any other DNS server, especially if you've already got load balancing taken care of by virtual IPs with kubeadm or HA proxy or something. So it's a thing. Hey, first time viewer, how are you? Welcome. You're on YouTube, just so you know. You're being recorded for YouTube. So say hi to YouTube. Way to YouTube. You want to see this? Check this out. SSH tab. Boom. It grabbed all of that from my Etsy host file and combined it with my config file, my SSH config file. And I have not used MDNS yet. I've thought about looking at it. Oh, no, I have used MDNS. That you're talking about Abahi stuff. Yeah, you don't need it. I don't need it. Not with Ansible. Not now. I just push my host file to everything all the time. It's like one command. It's for a home lab, it makes no sense for me. Avahi's good stuff. I like it. Mac comes with by default. That's how you know that, right? Mac since 2016 has been using Avahi to something.local. It's also the reason that you probably don't want to use .local as your domain. I use example.com for my domain. It's suggested that to use local LAN instead, but don't use .local. .local is used by internal DNS for Kubernetes and Avahi and other things like that. Home.arpa, that's a good one. Yeah, we're on Twitch. Yeah, we have case control. Local one of many domains. That's a good idea too. There's lots of ideas there. So yeah. Anyway, and let's see. So explained use of Etsy host tab completion over DNS. It's also faster than a DNS lookup, even on a local LAN, because it gets cached. Super cool. So anyway, example.com is not a real domain. It's reserved. The only reason I use example.com is because my videos end up being more useful because people can put example.com. I literally put example.com as my home domain. MDMS for home lab. I used to use it from a home lab a lot, and then I stopped doing it. Yeah. I do like it. I do like MDNS a lot. I do. I think it's cool. I just don't know if it would work in this case. See errata. Home.arpa? I don't know what they decided. It's reserved, but example.com does exist. It absolutely does. And it has something there, and let's hope they don't actually put something there. Yeah. You guys reject. I don't know. So, domain.tld. Yeah, that's a good thing too. Home.arpa is a DNS black hole forever. Oh, really? Huh. Lots of great ideas on what to do your internal thing. My stuff's all resolving locally anyway, so. Hey, I have a question. Here's a question for Tanifa or somebody who knows. Somebody suggested that your control-plane-endpoint should actually be fully qualified. What do you think? That this should be .example.com. This is my kubeip virtual IP load balancer. Do you think that you should fully qualify that? If you're going to use a domain name? Yeah. Okay. Well, I'll do that then. I think it's probably the safe thing to do. But I'm sure others do. I'm just wondering if it I don't imagine. I mean, if you just have to ensure that your search path is right on everything, I guess. I mean, I could see an endpoint node. I could see a host getting misconfigured in my imaginary company and having it not have a search path, and then it would fail. But if I add it, it'll be fine. So I think I've decided to go ahead and keep a full path there. In fact, I'm going to put that on my log. To use FQDN for what? I forgot the name of it. I did. Control-plane-endpoint. I should have that memorized. I should have this memorized by now. Control-plane-endpoint. I want to get so good with this that I can have this stuff just memorized. I can just type it out. Don't have to look anything up. Thank you. All right. Back to our certs. It's time to make some certs. I've been saying that forever, but local cluster domain though, I think. If you should use the local, the .local thing. No, it doesn't. No, because that is, I know that because we use it for the load balancer, and we know that is the network, like general network IP. That is not, and you see entry point into Kubernetes from the rest of your network. So all the kubectl stuff can be pointing to it and stuff. You can use a domain name. I chose to use a domain name instead of an IP. It does allow me to change that. That's left over from some recommendations somebody made earlier, using domain names when you can, because it allows you some IP flexibility. And I'm kind of game on that. It might clash with cluster.local. It's not going to. That one's not going to clash with cluster.local. No, because this is the control plane endpoint. It's different than the other stuff. The other stuff's all resolved internally within the Kubernetes cluster. That I'm pretty sure of. I mean, we'll find out, but I'm pretty sure that's totally different. The reason we have to have all these domain names and everything set up is because we're going to be using this for the certs, right? So, which I just realized I may have a problem with the example.com domain because of that, because I'm going to be creating root CAs that are tied to example.com that anybody can use. So it's the question of like, so, okay, we got to do this, because I know that you can tie certs to domains or IPs. And I think tying it to domain could be a problem if the domain is something anybody can use. So we might have uncovered a problem there. Will not mention anyone else? No, it won't. I mean, if it got out into the wild, it wouldn't be a problem, but still. I mean, let's pause there for a second though, because yes, I did. Mm-hmm. Yeah, it's in my search path on everything. Internal CA, you're fine. Yeah. For anything in public, yeah. That's a good point too, Mindsight. No one else can trust you to receive it. Yeah, that makes sense. How much sense would it make to actually use a legitimate DNS domain? I mean, I have rdbx.gg and stuff like that, right? So, when I set up my network, I went ahead with the example.com, but it might make sense if you're running a major provider. It would make sense, yeah. So, because then I could use, instead of using rdbx.gg, I could use something.rdbx.gg, yeah, would be what I would do. And then you would do, and then that would be my signing authority for everything internally. A cert that says I am example.com signed by A isn't going to be meaningful to a cert that says I am example.com signed by B. Oh, gotcha. I mean, I kind of think that the cute thing to do to make my fully qualified domain example.com might actually be a mistake. And so I'm pausing. We're about to enter this. I know that when we start creating certs, we're going to have to start locking them down to domain names and IPs. And so it's really, really important. I mean, we can come back and redo it, but it's really important that we have our network topology and the IP naming and our default domains and all that stuff. Those decisions have to be in stone before you start setting up certs, because the certs depend on it. And I'm just rethinking that. So rethinking use of example.com, perhaps rdvx.gg or local or LAN. Probably do lan.rdvx.gg instead. The API server one. And Hayden agrees with this. At least one person agrees with this. I think I'm going to go this route. One of the reasons I want to go this route is because, I mean, I could hypothetically, hear me out. So let's go back to our diagram of certs. I think you probably know where I'm going with this, right? Hypothetically, I could create a root CA that's tied to star.rdvx.gg. I already have one that is probably being used out there because of my CAs are not tied to anything. They are too. They're tied to the scope of the IPs that they apply to is definitely. I mean, we'll go look at it. But the point I'm trying to, okay, so, I mean, we're over time. I'm going to take another break and we'll come back and we'll actually get our hands dirty in cert creation. But what I'm saying here is, what I'm wondering is if I make one root CA to rule them all, and I actually get it from, that's only for leaf certs, would there be any value in me having a root CA, a root CA, and then my lan.rdvx.gg would be an intermediate CA that's signed by the root CA that's actually a legit cert on the internet? Is there any value to that? You see what I mean? I mean, it was a natural thought to have because of the whole rdvx.gg thing. To domain 2, but there are dragons. Not all clients implement that. You can't do that. CAs aren't certs on the internet. No, I'm talking about, okay, so CAs are like Letsencrypt, right? So let's say I go to Letsencrypt and I get them to sign my rdvx.gg cert, to give me a cert, and a private key that goes with the cert that is legitimized by a CA on the internet that's largely recognized, like Letsencrypt. Okay, so I go to Letsencrypt and I get rdvx.gg. That's a server cert. Is it only a server cert? It's not a CA cert, is what you're saying. It's a server only. It's not you can't use it to sign intermediate certs. That's what you're saying? The CA, this goes back to the original thing that y'all were telling me, that it's a totally different thing, that the internet certs are different than Kubernetes certs, that you don't have full access to it by actually using it. This is an important realization for me, so I'm going to talk it through. Will you legit cert have the ability to sign off on an intermediate CA and provide all usages? That's what I'm trying to ask. Let's Encrypt sets is CA equals false, critical. Oh. So it's a server only cert, which cannot be used to validate or to create or to sign or whatever intermediate certs at all. It has one specific purpose. So, okay, so that goes back to the thing that we were talking about earlier. CA certs like Let's Encrypt do not allow the type of certs needed for Kubernetes. So if I use the same domain, it's a completely different certificate that's not even going to see the light of day with anybody else. You'd be able to generate root trusted certificates. Well, that's a bad thing. Yeah. Really? There's no stopping you from doing that? I would think that they would allow you to generate intermediate ones and have them be lesser privileges than, the root from which it was generated. I would think that would be another class of certificate, but I guess not. I guess that's not a thing. So You can't use LA for your own intermediate CA, correct? Right. So, okay. So really the only practical purpose for using lambda.rbx.gg is that it is a domain I control, and it is not example.com. And that's it. That's really it. It's just a name. Nobody cares. How do you create a signed root CA or signed intermediate CA? Well, that is because we have to create our own top level type, and that's what they're trying to get at here. This right here, the kind server client server client server client server client. So something about a certificate kind, which I have no idea. We're going to get into that after the break. There are different types of certificates, and Letsencrypt only gives you a server certificate. It doesn't give, at least it has to be a server client type. The certificate also contains other flags such as key usage. One of them can allow the signing of other certificates, and that these aren't, because these are all intermediary. So that's something that we don't know. It's not described here. It's probably described elsewhere, but yeah. So we're gonna do that when we get into the signing, and we're gonna look at the actual content of the cert. So that's coming next. Let's take a break though. Until then, stay tuned, YouTube. It's very likely our last one, and we're gonna do actual cert creation right now and just get muddy and messy and look at them and see what's in them now. Now that we've got our kind of our summary. I have to look at the command. So openssl x509 in ca.crt out text, no output.txt. So I'm going to read about the openssl command. And we're not going to really go crazy with it. I do want to just make one. We do have a CA here that we started to mess with. Create a CA in this hour. I would really like that. But I don't regret the length of time it's taken so far to do all this myself personally. So openssl, I don't even know if I have it. Yes, I do. Okay, so openssl x509. I know it's a pain, but I want to do it that way. Help, hell, yes. And wait, what did I lose here? In ca.crt, noout txt. I have no idea what that is, but it's definitely not a fluid API. We've been talking about it. Fluid API is the name of the APIs that I built with Bonsai that I didn't know how to name. That existing could, let's see, could not open a file. Oh, that was suggesting that we use that to go look at the ones that were created during the kubeadm thing. All right, let's go do that. I get you now. Yeah, let's go on the control one and go into etc. Let's do sudo. Come on. All right, so that show vi cd etc Kubernetes cd. Okay, so we have the admin.conf file, which I'm just going to open up. No, there's no secrets in here. You wouldn't do this if it was a real thing. This is a client key data. I mean, this is the file that you can cheat and put it anywhere and it'll work. But you shouldn't do that. A controller manager conf, I haven't seen that. Let's go look. It's got the certs in it as well. Client key data also highly, you would never show that on a stream if you cared about your cluster. And it was internet facing or something. And then we have the PKI stuff. Oh, by the way, while we're here, just a really quick drive by with the kube VIP server. So we set this stuff up using the kubevip command that we made. We actually called the container after we installed it, and it set up. This is the thing that does this is our load balancer. That gives us a virtual IP. Anyway, if we want to go back and look at that, we covered that a couple days ago. So there's our CRT. Here's all our certs. So we have the ARP. I'm going to see if I can identify them. We have all the etcd certs, the front proxy stuff, which is apparently related to API extension servers, which are not responsible for custom CRTs. Inside, no, it's not inside the cluster. It's in a static pod. So it does internal load balancing like MetaLB, and it also does the virtual IP, which is sort of outside of the cluster, even though it's a static pod. Yeah, there's certs, a whole bunch of certs here that we can look at. So ca.cert, this has got to be the top level CA. Let's go read the definition of them. So the CA is the thing that's signing this and this and this. Assuming it's an RVIP. Yeah, it is. Yeah, it's using ARP. And the HI stuff lets you use service detection, but this one uses ARP. Which I kind of want to see if it's going to work at work, because right now we're just using round robin DNS, which is totally stupid, in my opinion. I don't know. I don't find that to be the right way to do it at this moment. All right, so here's a cert. Let's go look at it from the very top. I'm going to go to the very top of it. So, yeah, ARP needs to be on the same Ethernet segment. Yeah, it is. But it doesn't have to be on the same Ethernet segment as the clients accessing the BIP, though. The virtual IP has to be on the same ARP segment as all of the servers that it balances to. That's it, right? That's the only requirement. I mean, I happen to have both because I'm using it on my homeland, but I want to be sure of that, because when I talk to the network guys tomorrow, I'm going to do that. Tomorrow I'm going to suggest we actually do that. I'm going to ask them if I can put QVIP on there and make sure it doesn't blow up their ARP caches and stuff. Not only does it broadcast it, but when you do an IPA, it lists an additional IP under the IPA output for that exact same interface. Pretty cool. Yeah, I wasn't expecting that. I did IP-C space-A, and I saw that my virtual IP was listed at 2 IPs assigned to a given interface, to the main default interface, and one of them was the actual one and the other one was the virtual IP, but there was no distinct, you couldn't tell the difference. You want to see? It's kind of cool. And that kind of blew me away. I wasn't expecting that. So, I mean, this has got all kinds of stuff on it now, but so here's the main interface, yeah? So here we have iNet, boom, and we have iNet 69, and it gave it /32, which is really weird to me. I don't know why it would do /32, but that's what it does. Yeah, it works really nice, and what's his name's not here. He was pretty vocal about us giving QVIP a try, and got really upset when we started to talk about HA proxy instead, which can also be done as a static pod. But yeah, I find this extremely interesting. Nice VIP. What I think is cool is that, I mean, how can you look at these 2 IP numbers and know which one is the real one? I know this one's the real one because that's the one I assigned to it. But there's no other indicator that this isn't real. That's what I'm trying to say. It's not the /32 one. They're all real. The thing that's weird about this is that this is totally implemented in software. I mean, strictly speaking, the TCP/IP stack for the kernel is software. So this is just additional software, but I just find it interesting because it's implemented in user space. QVIP doesn't run as, I mean, actually it does, because we had to turn on network bridging in order to do any of this stuff. So the static pods are using their ability to deal with network configuration because you've activated bridging. And so the QVIP, that must be what it's doing. I really want to read the source code of QVIP. I'm super interested in it. Because this, I mean, if I were to look at this, I was like, how do I know, you know, if so pretend I'm administering the server. I mean, we're so far away from openssl at the moment, but if I were to come to the system, you know, if I were to come to this system and I were trying to define, okay, which one's my control plane node, you know, endpoint IP, the real is /16, the VIP is /32. Is it always /32? I mean, that blocks out the whole fucking thing. Is that why it's that's why it's virtual? Is it's literally got a subnet that masks the entire thing? I think that's it, right? I mean, this mask is like the entire thing. So is it safe to say that virtual IPs generally use a /32 subnet mask? Is that a general thing? The subnet mask, yeah. Here isn't a layer to answer that question, right? I know, but I'm just trying to dispel confusion. If I were to run an IP, if I were to come to this, or an admin were to come to this at work after I set this up, and they were to do an IPA, and they were to see this, they'd be like, "What the hell? Why do we have two IPs here?" And then this would be the indicator that, oh, that's a virtual IP. Keep Live does the same. Does it really? That's good to know. So you can make a guess if the address is actually routed. Yeah. Okay, that's good. That's good. I'm gonna put that in my log really quick. So, VIP gives additional IP with /32 to distinguish, but shows in IP-CA. Yeah, I mean, that's a little tidbit of wisdom I want to keep in mind there. And that really weird interface name, yeah. It's because they're weird. This is a Dell Optiplex. I don't know. We could Alice. Yeah, we're gonna be running QVIP and everything. Mm-hmm. I like /32 CIDRs. Explain that. What is a /32 CIDR? Is that something that's commonly done to identify a virtual IP in practice? Because I don't know the networking on that to understand that enough. I know what the mask is. I don't need that explained to me. What I want to know is why the hell would you do it? And when do people do it? So it's just a single IP. Yeah. You do it to not take a full subnet up. Well, yeah. Then you route things through it. So it goes to say that anytime you see a /32, which is extremely unusual, you've assigned one specific IP, that specific IP, to that interface and nothing else. And in that case, the case of assigning a single IP to an interface, which is normally not done. Normally there's a range to an interface, right? No, that's not true. No, there usually is. Usually the interface is one IP among many, and therefore the subnet would be larger, implying that, hey, this is the IP by which this device or this interface on this device participates in a larger network world, right? Oh, that was very nice. But if you see a /32, then you're saying, okay, somebody has explicitly said, I want only this IP address to apply to this specific interface, period. And it's not going to participate with anybody else. And when you see that, then you would think, okay, that's very unique. That's very unique. That's got to be something to do with virtual IPs, or for some reason somebody wanted to hard code an IP to this interface at the interface layer. Okay, that's why it would be weird. I mean, because as soon as you see a 32, you're like, what the hell? That's like an internet of one. That's like a subnet of one. What the hell? That's what it is. A slash 32 is a subnet of one. Okay. Or it has no broadcast address. Did that one not have a broadcast address? Well, it wouldn't have a broadcast address because it's just one IP. Espil, thank you for saying so. That's very kind. There's lots of good Twitch streamers. So I like that a lot. 32 digits. Yeah, you can do lots of tricks with that. My eyes have been open to the possibilities, honestly. I'm not even exaggerating. I'm like, honestly, that's the first. I saw that the other night, and I didn't really dwell on it. I was like, wait, that's the same IP, that silly IP that we made for the VIP. And I happen to know that IP is going to be assigned to 2 other physical interfaces before this is done. And I'm like, that's super interesting. Slash 31. Well, slash 31, you would get, how many would you get? Would you get 2 on that one? 31, you'd get, no, 31, you'd get like 8, right? 7, sorry. Is where, is similar with the 32. 31 is 2. Oh, it is 2, right. Yeah, 2 to the first. Sorry, I'm like, it's getting late, I have to admit. We're supposed to go back to openssl, I know, but this is fun. I like this. All right, so, yeah, and as somebody pointed out, there's no broadcast address. There's no BRD. That means you can't send packets to the whole thing. By the way, speaking of something that sends packets to the whole thing, guess what tmux does? I'm going to show this to you, not today, but later. When I'm running my fishies on tmux, my blinky lights on all my switches light the fuck up. Every single one of them. Because there's something going on. There's something going on with the way the fishies are generated to the screen that causes a broadcast to every single IP interface. And all the lights are and I can control it completely. I can turn it off and none of the lights are on. It's the craziest thing. So there's something about tmux and fishies, a combination that causes a broadcast, an IP broadcast that matches the animation steps. It's really weird. It's really freaking weird. So I didn't believe it. I was like, why are my things like blinking like crazy? And then I turned the fish off and it stopped. I'm talking about the fish on my VM running on Anton. We're talking about the fish running on Anton and my VM on Windows. We're not even talking about the ones over running on my server over there. We're talking about over here. So that means that whatever the thing is doing, it's spamming my entire network. I still want to figure it out. I still want to figure it out. It was so weird. Blinking lights do have a purpose. They really do. I mean, I'm not sure. I don't have a vulnerability there. I might. Slash 30 for private IPs. I did not know that. Did not know that. Okay. Back to openssl. And somewhere here, we are on a system with openssl. Here we go. So let's look at a certificate. It's not a YAML file. It's a certificate file. It has no structure whatsoever. It's very unique. You have to go look at RFC X509 to understand that. But let's do that. Let's break it down. Networking is pretty fascinating when it's not like destroying. When you have time to make it fascinating. It has structure. X509 is the structure. What are you talking about, silly? I know it does have structure. I get it. Okay. It's not YAML though. That's what I'm trying to say. Certificate data version 3. Yeah, when network's not working, it's not cool. But when it's working, like with this, when you can screw around and not get in trouble, it's NAML. I don't think so. There's time to be fascinated, exactly. But usually that's not the case, though. Usually when you're studying networking, you're like frazzled and people are losing billions of dollars. Not even kidding. On the order of millions, probably. We've had two 48-hour GPFS outages that took down the entire fucking company. More than 20,000 employees all over the entire world. The cost associated with that fuck up cannot be overstated. I just at this level, I mean just the GPU rental loss for the day for the A100s and the V100 GPUs, which is on the order of $200-300 per GPU. Just that one thing, just for not being able to use those things, it's insane. This is why network engineers make so much money, because if they get shit wrong, I mean, the entire company goes down. It's also why I don't like Cloudflare. To harp on a old wound again. MTU memes. I don't know, man. A mammal is an animal and animals are mammals. Lol. Broken networks are a learning opportunity. Well said. Twist message too large, please be sent. Okay, so here we go. Hey, issuer, CN equals Kubernetes. So this is my Kubernetes certificate, which matches our documentation. It said here the default CN name was kubernetes.ca, which is a lie. They lied to me. It's not kubernetes-ca. It's Kubernetes. I think they lied. Either that or this is a different CA. Woohoo. They say that CACN is Kubernetes CA when the fact is Kubernetes. LBG just pointed out that very fact. Those fucking liars. They're trying their hardest. I don't mean it. I don't mean that. But it's so frustrating. Depends on who makes the CA. Okay, fine. This, at least the docs are make an issue in the docs. No. If I was doing that, I would never do anything else. It already takes me forever to do anything. PRA can make you make it. I don't want to make it. You make it. You guys got all that copious free time to watch me. Go do it. All right. So while you're watching me, maybe not me, the people who actually know what they're doing, the rest of the community. Yeah, but we are learning as well. Kubernetes is not. This should be Kubernetes-ca. Validity not before October. This is going to expire in 2032. How about that? Obviously making a CIV RBX Rob on Twitch. October 4th, 2032. Man, I wonder if I'll be alive in 2032. I want to think so. I'm at the age when they give you a renewal on your driver's license, they like bump it out like 25 years. And like, look, if you haven't died in a car by now... I'm not even kidding. It's like I was looking at my license like 2032, 2035 or some shit like that. I'm like, okay, damn, I hope I'm alive then. It's serious, it's crazy. I don't know. It's like it's weird. It's not like every 5 years or every 6 years and then like gets bigger. It's like on some scale, the longer you live, the more infrequently you need to, like when you're a teen, you got to renew it like every 6 months or some shit. As soon as you hit, which is bad because, that's why all those people who can't see the road are like, grandpaing down the road. They don't have anything to worry about. That driver's license is going to be in their pocket for the next 25 years. Can you tell things are going downhill? Let's get some work done and then we'll be silly. CN equals Kubernetes. Is it 4 years? Well, it felt like more to me. Yeah, it's not as funny when it's only 4 years. So I'll lie and say it's 10 years. How about that? It should be required every year. I do think that's true. I agree. I cannot parallel park for shit. My wife can. She's from New York. Mossy, no. Why would you ask such a question? Okay. Subject CN equals Kubernetes. Subject public key information, public key algorithm, RSA encryption. Oh my God, help us all. Okay, at least it's 2048. At least it's 2048. At least, for the third time, it's 2048. 1028 encryption, 1028-bit RSA encryption is the devil. You should not do that. I don't think you should do RSA encryption at all. 2048, yeah, write that down. 6,500, 536 bits. Yeah, I think so. CN is just a fancy name. The public key reference make it self-signed. The names are fluff. Blade Runner 2048. I forgot about that. Maybe I have to watch that. I'm losing interest because I'm looking at a certificate. Okay, I have a question. Why don't I just copy these certificates out and make them official? If I was going to be lazy and not use OpenSSL, couldn't I just use kubeadm and just say, hey, Etsy Kubernetes, I'm going to copy you all out and see that thing that says no, you know why? Because the CA stuff is all based on Kubernetes info and I want to put my own stuff in there. I changed my mind. So this is the root CA. Actually, this isn't the root CA. This isn't the root CA. Where's the root CA? I am confused. All right, let me, wait. There's a service account. We got the key and the pub. We have API server and the CA desert. Yeah, but I thought we were going to have a root CA. Oh, wait. You can create a single root CA controlled by the administrator. This root CA can then create multiple intermediate CAs and delegate it for the creation of Kubernetes itself. No, not today. No, I am spent. I want to so bad though. Maybe tonight. No, it's Sunday night. There's not going to be anything happening. Or pub crawls. Question. All right, so kubeadm, these are top level CAs then. True story or false story? The default Kubernetes certificate setup is not a root CA pyramid like we have been drawing. It is a different kind of pyramid. Right? The default setup omits the intermediate. So that means that... Oh, wait. So I really want to understand this. Where are you? Okay, so Kubernetes General CA. Well, I'm going to go look at the certs and it'll tell us. What I'm asking is the CA dot whatever cert, is that one the one that signs the other ones or not? I think it is. It's either generating multiple root CAs or ca.cert is a root CA and it's being used to sign the other ones. Those are not the same though. And Tony Foss telling me it's the second. Okay, there's a way to prove that, yeah? So if we look in let's look in SA, let's look in sa.pub. Wait, what? This is just a pub private key pair. That's not even, what the hell? This is just a good old RSA key. That's just an RSA key. That's not even a cert. Wait. They mentioned that, but now I understand where they were saying. That's just a key. Okay, wait. It actually says that. Yeah, that's cert. Yes, let's look at that one. So, server digital signature, kind map sticks, 509 key usage, or copying custom CA private keys is referred to traditional CA and kubeadm documentation. You're copying to your cluster CA certificates without private keys. Refer to external CA in the kubeadm documentation. If you are comparing the above list to kubeadm generated PKI, please be aware that kubeetcd, etcd peer, and kubeetcd health check client certificates are not generated in case of external etcd. External etcd. And that's very important. We actually run external etcds, so it's kind of stupid though, because we run external etcd even though we're doing stacked architecture, because it's all on the same machine. And I'm going to question that tomorrow with my manager. etcd-ca key, kubeadm server, etcd-k file. All right. There is a comment, however, up here about it, and I want to read it again. In general, CA is used inside a cluster. Case can sign certificates too. Yeah, the CA is going to have to do all that. Client certificates from proxy, schedule API. We did all that. Where is the reference to the service account one? I remember reading it. All paths and documentation relative to the directory exception of account certificates, which kubeadm places in etc Kubernetes. Configure. There is a reference to it. There's a reference to just the key in here somewhere. I'm trying to find it again. Oh, there it is. Okay. So in this case, the ca.crt is, so we're going to confirm that, but that's what Tanifa just said. On top of the above CAs, it is also necessary to get a public key pair, a public-private key pair. That is not a cert for the service account manager. And this is a good old thing. This would work with SSH or anything, right? The SA.key pair. We have the private key, and this looks like it's encoded just the same as SSH would do, or GPG encoding or any of that. So this is just a legit key. It's a good old RSA key, good old fashioned key. There's no cert associated with that key at all. Okay, good to know that. The ca.key is the thing that we would normally want to keep private. This is the private key for the certificate authority that we're going to find out right now signs everything else. Invalidated though, no. So ca.cert, we already looked at this. What? I'm confused. Did I copy something? Oh, please tell me I didn't copy something on accident. I thought that had metadata in it just 2 seconds ago. Oh, we used openssl to view it. Wait a second. Oh, because it's signed. It's a certificate, so all the data has been encoded with ASCII armor. I see. Does that the same? That's not the same for the SA key though. The SA key is an actual key that says begin RSA private key. Oh, I just saw the encoding and I kind of glazed over that. Yeah. Okay. So the encoding, there are 3 different things, even though they're using base 64 encoding. So gotcha. So this is actually a cert, even though it looks like another RSA thing. It just begins cert. So ca.key is an actual key. It's going to say RSA private key. Yeah. Okay. So the cert has the public key, but all the other mono stuff in it. So we have to open that using the tool, and that's where the openssl came in. Okay. I'm recreating my steps here. OpenSSL X509 input ca.crt, and that'll just give us that, but we want to have dash text. That was interesting. So I don't think I did it right, but it did it. I think the thing would turn off the cert as well. This is the thing that says its name is Kubernetes. And it admits the PEM. What's a PEM? What's a PEM? I've seen that used all the time. I don't know what it is. What is a PEM? As a PEM file to store SSL certificates and their associated private keys. Private or public? A PEM. Okay. A PEM is just a format as opposed to ASN1. Okay, well, now I know. Thank you for the follow. So I learned what a PEM is. PEM is just a format for containing a TLS cert meta and keys. Hey. Keys or key? Privacy enhanced mail. Did not know what that meant. Now I do. Okay. I've seen .pems around all the time though. There are PEM. I've seen .pem used as a thing, and that's why I'm curious. Yeah. .crt.key pub. Are they all PEM? How is this a PEM? Because that's the same as the GPG output. Wait, I have a question. sa.key-text store routines. It says I don't know what to do. It's probably not a 509, right? It's RSA. Oh, look at that. PM is begin title base 64. Is it always begin title? So PEM files are used for GPG armoring keys as well. Because that's the same exact format. Same with SSH keys. So those must all be PEM. Is that true or false? Begin private keys. So are you telling me PEM files across the board? Data cat safe on email safe. That's all we're talking about. That I did not know that. I did not know that. I did not know that. I've been looking at PEM files this whole time. I did not know. PEM is apparently also used for ASCII armor. GPG and SSH keys. Okay, that's very good to know. I mean, I didn't realize that had a name. I've been using that my whole life. I didn't know it had a name. I mean it. For like 25 years I've been using that. I did not know that. So, I mean, I know what the begin thing. In fact, I've written them. I've written code that generates it. When I made a password storing tool, I actually generated the lines that had to be there. And I used the internal all of the internal stuff for Go. And I had extreme interactions with these ASCII armored files. I had no idea the whole entire time they were called PEM. Live and learn. Until just now, either. Yeah. Well, there you go. Live and learn. Okay. So. Alrighty. Well. Apparently, there's nothing in there though for us to see. So. All right. What's first? Let's see if there's any signs that the API server.crt file has actually been signed by the ca.crt file, confirming Tanifa's claim that the ca.cert is the root ca that's automatically created by kubeadm. If that claim is true, then every other certificate in here should have some indication that it's been signed with ca.crt. Otherwise, the Kubernetes is the name, not -ca. So let's see what's in there. I mean, if we look at the PEM file by itself, we see the PEM file. See, I'm using PEM like a lot now because I want to internalize it. This is a PEM file. It's just an encoded thing with this thing in it. The only thing that makes it a PEM file is it is base 64 encoding. It has -- begin at the beginning, and that's it. And that constitutes a PEM file no matter what it has in it. It might have random different things in there. So in order to get to what's in there, we need to use openssl or some equiv. Tell it what the format is, x509, and we want to see it. We want to see it. And so we need to tell it is our input. Our input is api.crt.out. Oh no, it didn't turn it into actual text. So let's do -txt. And what is it? No out. which will omit the base 64 encoding, and then we get the actual thing. In fact, we could actually violate. We'll just do foo dot. What is this format? I wonder if it has VI stuff. What's the suffix? CRT? PEM? It's not PEM, so I'm trying to get some VI syntax color highlighting here. Will not show all of its OIDs in a cert. That's not good. This format is rendering of X509. X509. So let's try X509. I'm going out on a limb here and see there's like the format's not PEM. PEM is the encoded one, right? Right. So that would be wrong. So let's do foo. X509 is the specification of the format. If it's going to have one, that's going to be it. vi foo.x509, and there is no coloring for 509. And of course, this means I'm going to immediately look and see if there's a Vim plugin for looking at 509 certificates, because there is. I just have to. I'm sorry. Vim X509 plugin. The 12 best VM plugins. I mean, this is a real long shot. We got to have colors to look at our certificates. Hello. We're not savages. We're not savages. Apparently there's not one. The key usage is making high order. We could actually do that, Bellum. Don't tempt me. I'll do it. Vim plug, minimalist Vim plug. No, we don't need that. God damn it. Syntax highlighting. Because God knows I want to write my own. Inform for information, I guess. It's not on the map page. Oh, really? Syntax on. Apparently there's no syntax on here. I'm sad. There's no obvious answer. I would have expected an answer by now. I don't see it. I mean, maybe that's the reason to use NeoVim, just so I can see my X509 certificates. It's a joke. It's a joke. Okay. How do I disable Vim syntax? I don't want to disable it. I want to enable it. Okay. Most of the people looking at the content for cert type have green text. It took me a while, but I got it. Braille syntax. Yes. Text is juvenile. Colors text is juvenile. That is the exact quote from Pike. Yeah, Mr. Pike. Mr. I Made Go and Unicode. PEM decoder. What? LBG, what'd you find? LBG's on board with the color stuff. Paste your PEM data here. I'm sure they're just gonna. That's a great way to trick people out of their super secure stuff. Honeypot for your private keys. Yeah, paste your PEM data here. We'll format it for you really nicely. Oh, I'm getting into the giddy phase of the day. If you can only upload the cert, yeah. If it's just the public, because they didn't have the key. They wouldn't have the key, so it is safe. Yeah. Hindsight JavaScript is like. All I see is CA. I don't see certs anymore. Just CA, tree, brunette, blonde. I'm trying to stay on track. So what are we doing with PKI? Good question. What are we doing with PKI? Right now I'm trying to syntax highlight my X509 certificates because I can't stand looking at them in black and white. It's just too much. That's how I roll. Damn it. When are we generating the CA? We need to do it soon. We need to generate a CA soon. We're definitely going to do that. Yeah. Go set up a dog tag server and come back to me when you can start crying. Oh, man, I don't want to do that. Syntax auto is on for Vim editor by default. Nuh-uh. Not for this. Apparently, it's not a thing. I cannot believe it's not a thing. I'm going... One last attempt. I'm going to GitHub. So we're looking for colors for X509. I mean, this is the first thing anybody dealing with certificates thinks. How come I don't have syntax highlighting in my read-only file? Vim plug. Oh, hey, look, I found Vim. Yeah. How about this? Ooh, Vim Moonfly colors. What's that about? NeoVim. Oh my god. Oh, that's like every occurrence of the word Vim in every file in all of GitHub. I should probably isolate. Okay, fine. I'm done. I've had enough. I also have exceeded my I may or may not give like lots of rep to someone who gets me some colors for that. Gotta have my colors. I mean, look, it would be so much easier to read if it had color. Okay, so we've got our key. We just okay. Wait a second. Okay, so that's the regular CA. Okay, so how does that differ from YAML? Maybe no, I don't. Well, maybe. I mean that's that would be. Oh, you're a genius! Holy shit, you're a genius! You're a genius. I thought it was YAML when I first opened it. It's not quite happy though. It's happier. Yeah. 509 is YAML. It's pretty close to YAML, but it's not YAML. I mean, in a pinch, when you want color. Yeah. I mean, it's good enough. And when I looked at it, I was like, is this YAML? And I thought, no, because this validity, whatever the fuck that is. Why doesn't this not have a comma? They could have just put a colon there and it would have been YAML. It would have been good. It could call it a day. In fact, why don't they use YAML? They could use YAML here for no problem. Why do I hate NeoVim? I don't hate NeoVim. I don't. I find it irrelevant. You have to install it. Bottom line. Why are you using NeoVim? I may ask that. Consider that. You don't have to answer right now. Every time anybody tells me they use NeoVim, I ask why. And every reason they give me, I'm like, you can do that with Vim. And they're like, oh, really? All right. 1988? Holy cow. The original YAML. The OG YAML X509. Okay, so all right. What are we looking at here? Okay, we're looking at the same one. Let's look at shall we? Let's look at API. You know what? You want to see something here? Wait for it. Oh, that was foo.pem. That was wait, what? foo.x509. How about foo.yaml? That'll really confuse everybody. It's it's not YAML. Foo.pem is a PEM. It's not, yes. Can't see a key. I'm super confused. Oh, no, I'm not confused. Look, issuer, CN equals Kubernetes, subject equals CN equals Kube API server. Boom. Okay, so that's what I was looking for. That's all I wanted to look for. It says the issuer is the CA. All right, so we're good. We are good. Now, let's do the same for the other ones. I don't think it's worth doing, but we're going to do it anyway. So, in fact, we can actually pipe this. to view. Oh, maybe not. Maybe not. Maybe not. I mean, I don't know. Foo.yaml. And then vi foo.yaml. Okay, so this one is Kube API server. And API server dash etc dash client. I am going to look at all of them. I know. I don't care if you don't like it. I'm doing it anyway. etcd, not ecd. Okay, so this is issued by what? That is not what I was expecting. This means that etccd is a CA someplace. I'm guessing it's probably in here. Yeah. So etcd has its own CA, which we will now digest for educational purposes. ca.cert. Why does etcd have its own CA? They don't each have their own CA. Shoot by GoDaddy. San Echoes etcd CA. Hey, look, the subject and the issuer are the same. That's how you know it's a root CA. Am I right? Am I right? Am I right? Am I right? I'm going to put that in here. If the issuer and the that's how you know it's self-signed. Yep. Okay, I'm learning things. Self-signed CA root CA etc. means has, let's see, has issuer CN equals I mean, if you're going to write code for that, that's how you would do it. Subject. Why is it in the subject line, though? I mean, that seems odd to me. It seems like there should be some other identifying characteristic there. There are trust anchors, but you can use this heuristic for now. There are something called trust anchors, which I have no idea what that is. But, because 1988. Subject is the ident for the cert. Of course it is. But it is, after all. There's no other thing down here that's a better identifier, is there? Apparently not. Apparently not. CA true. How do we know it's a CA? I scrolled right by it. Well, subject key is the authority key. Okay. Exponent 65537. Extension key usage critical. Oh. Somebody told me that when you get a key, this is cool. This is important. This is important to me. I'm going to tell you why. So somebody earlier said in their explanation of why you can't use Letsencrypt certificates as your CA is because they only have type certificate and they don't have key usage critical set in the certificate. So I am taking a note of that because that is how you know. Is not set on certs from Letsencrypt, for example. I just want to make a note of that. If the client does not know how to parse this issue, should fail validation. Somebody said, kind of in passing, they said there are a number of things about the certificate that are lacking in a Letsencrypt issued certificate. That's why you can't use them for Kubernetes. And I just kind of glazed over that and trusted them. And I can see some. The first one was you only get a server type. And yeah, in order to do this stuff, you have to have a server and a client. And the second one, what somebody mentioned, was the critical line. So the critical line is there, and now we can see that. That's the field name. The values are what matters. Yeah. I think I put that. It's not on a search. Okay. But so, I mean, the reason I'm interested in this is so I can look at the cert and see where it was issued. I mean, it should say issuer, and it would say have the CA, internationally registered, whatever. Key usage critical. They all have that? Yeah, but it wouldn't have that if it had come from you got me wanting to look at my certificates coming from Letsencrypt just to compare. Mm-hmm. Yeah, the value of critical. Is that not clear from that comment? That's what I meant. How about that? Usage dot? What the hell is that? Any usage whatsoever. Why do I need these certs? To set up Kubernetes in a way that's safe. Because we're crypto nerds, yes. We are definitely crypto nerds. I am not a crypto nerd. Critical, oh wow, look at that. Basic constraint, CA equals true. That means it is a CA. Ooh. Also look for CA true, right? Is that a value? Is that a value of the basic constraints? I don't understand that. I'd have to look up X509. Hey, steroids. I just laugh because your name's funny. So the value is on the next line. So this is kind of like, so if I'm trying to understand X509 without reading the RFC, which I'm inclined to do over a brunch someday, is this here is something like the type. And this here is something about the scope of the thing that you're reading about. And the fact that it's critical means that, and then this is the actual value of this thing. So it's truly not YAML, right? This is the actual value. Digital signature, key, encipherment, certificate, sign. Digital signature, key encipherment, and certificate signing. This is really, really, really informational to me. Because this really gives me a handle right away about what's going on. So I can open up the certificate and know that this thing can be used for signing, encipherments of keys, and certificates and digital signatures, as well as certificate signing. Is address still in my passport supposed to work? Did not pass validation. Yes. The subject key identifier. No idea what that is. DNS etcd-ca subject alternative names. Someplace in here we're going to see the scope of the certificates, and I haven't found that yet, but I do know that's a thing. The thing that contains the IP addresses and the wildcards and stuff. I know that's a thing. The signature value, this is the actual, if you were looking at GPG signature, that would be the stuff at the bottom that's like cordoned off with like the lines. The SAN. This was being said, that's not a thing for CA certs. Yeah, that's what I'm trying to say. So, the whole domain thing does not apply to CA. So if it says CA equals true, you're not going to see that, right? Let me make a closer look then at the one that was a actual cert that had been, it was not a self-signed cert. It was one that had been actually issued. And that was AP server etcd as one of them. So this one is signed by etcd CA. Assuming I'm not an idiot. Let me see if I can find it again. Let's what was the one? What were we looking at? I mean, we can learn anything, but let's look at API server.cert. How's it going, Magic? God damn it. API, where are we? Oh, we're in etcd, that's why. All right, so I'm really kind of digesting this. So, good old SHA as a server certificate. Yes, you can. All right, but if the pub key crypto is exiting to you guys, then Zkey would blow up your. Yes, probably true. No, I'm not hacking. No, I'm not hacking. I'm trying to set up my Kubernetes cluster, and basically I'm trying to really get my head around certificates. Which, by the way, if you want to be a hacker, having like really core knowledge of certificates is probably the most important thing you could ever learn in terms of hacking. So you definitely want to learn this stuff. Yes, hexadecimal is hacking. Got lost about 4 hours ago. All right, so here we see that issuer CN is Kubernetes. We see that it's the subject and the issuer are not the same. So right away, we know that this is not a CA. And if we go down to the bottom, it should say usage, and we do not see, there it is, basic constraints, CA equals false. This is not a CA. This means this is a leaf, I'm guessing. It's a leaf cert. And it is not self-signed. It's signed by Kubernetes, the Kubernetes CA. And that is ca.crt. And then we have all the other stuff. So here it says critical. It said that this one can be used for digital signing and key encipherment, but not certificate signing because it's not a CA. So that's super interesting. And then we look down here. And then let's see. Certificate is the list of how you can use it. I think you're right. How you can use it is really the thing. So then we have TLS web server authentication, extended key usage. Interesting. And this was an API server, so one of its usages is as a web server authentication, which is exactly what the REST API is going to do. I'm super curious to see how that field is filled out for some of the other certs, like the Kubelet cert, for example, which I assume is going to be the same because they're all talking over HTTP, which is considered web TLS authentication. So interesting. You can run in the openssl command with -c to get C output. Really? Just plain old x509s. Yes. Critical. So here we go. Subject alternative DNS control. So this is where people were telling me all the possible DNS names you can use, right? So here are all the DNSs that can use it. Control 1, Kate's, Kubernetes, Kubernetes.default. This is interesting because it doesn't have the fully qualified Kate's name because of the client endpoint that I set to be Kate's and not Kate's.example.whatever. Which means I'm going to tear down the cluster and redo it and reset my search to the other. So that would be Kubernetes.default, Kubernetes.default.src. These are all the internal Kubernetes things. This here is a service IP. You can tell right away because of the cluster.local, which you can set, by the way, when you're doing your kubeadm init. I saw that. That was an option on the command line. You can set whatever your base domain is for your internal Kubernetes domain resolution. IP address 10.96.0.1, that is set by the --service CIDR argument, and that is the default. That is not ever visible outside. The actual IP address on the host network, the outside network, that's this one, and that's control 1. That's not a broadcast IP. That's an actual IP. Or it's not a router or anything. That's the first of my control planes. OpenXPXE. We're gonna do some OpenXPXE later, but not right now. The SAN can have IPs. That's what I was mentioning. The SAN can have IPs. I would think that would be here, right? So this is for the API server. Okay, so I'm guessing that we're going to have to make a new cert for each control plane, right? URIs, email addresses, directories. Yeah. This has control 1 for the local DNS. I noticed, and it also has the local IP address. So that suggests that if we're going to make our own certs and we don't use kubeadm for it, which in this case, God, I'm kind of leaning toward using kubeadm for this because kubeadm has all of this internal knowledge about DNS resolution. If I don't do that, I'm going to have to pass all that to openssl. I'm having a feeling, right? I'm going to have to pass all that, and you can't change it, right? I mean, once you deploy it, you can't change that. You have to issue a new cert if you want to give it. This is a thing where people screw up all the time. They don't include the proper scope in here, or they include too broad of a scope. Yeah, everybody says that. I'd use the admin tool because, yeah, complex. Yeah, this is where cert management is important. It's why cert managers think, yeah. So the reason that I would use kubeadm is because when you use the kubeadm cert installation or you're using a NIT, it's going to actually infer these IP numbers directly. Otherwise, you'd have to specifically provide them to, and that's documented kind of in Kelsey Hightower's like thing. You'd have to specifically make them for that control endpoint, and do it that way. Cert Manager also supports Acme, so you can also use Letsencrypt to issue the cert. What? For Cube, that's all in my home lab. Yeah, go on GitHub, go to artifacts/home lab, one word. That's all listed there. This really puts me in a quandary because I was hell bent on doing this with openssl, which is technically the hard way, even harder than Kelsey Hightower, who uses the Cloudflare shit, which allows JSON for all of this. And if you don't believe me, it's right here. And so, I mean, it's so easy to get that wrong. Oh, that was very nice. Thank you, Tony Fob. I think I figured out authentication solution building Kubernetes operations is giving me a pain. Yeah. You're making actual operators. I want to share a fancy tool for tinkering with CA. Do you have a tool for tinkering with CA? I mean, I'm open to all kinds of options here. Yeah, just don't dump your stuff in there. What is this? You can like put all your stuff in here. Generate private key. Shit, that's cool. Is that RSA? RSA private? Yep. The docs have a nice template for if you want to do it from command line. What doc is this? It's another doc that's not linked from any of the other docs. What is this called? Generate certificates manually. Oh, shit. Is this like... I think this is actually linked from the other one that we didn't really get to. Easy RSA. OpenSSL. Oh, you can use Easy RSA if you want, but right. Create a config file for generate certificate. CSR. They use INI apparently, or TOML. I don't know what that is. CFSL is a nice tool, but I don't know, man. I don't know. I know it's in Go. I mean, everybody loves to use it. So, I mean, the fact that it's JSON already makes me happy because I can actually do it in YAML and then convert it over. I bet it even takes YAML. Yeah. Create my own and go. No. Vault is your CA. I don't know if I want to use Vault. And I don't think Keycloak has anything like this. That's all OAuth stuff. Finding the CFSL download is tricky. This is true. I mean... Yeah. Distributing self-signed cert. Updating certificates. Sudo copy over to local share CA certs. See, that's where I would actually want to put mine. Sudo update CA certs. If you is that the natural place to put them? I think they're already there. I think if you install CA certificates, which you always have to do in any kind of browser, I mean any kind of container, right? It's one of the main dependencies that's always lost. You make a container, you're like, oh yeah, I need CA container. You can't curl anything until you have the CA certs. I'm curious to see where it puts them by default. I'm gonna see right now. I'm thinking that this user local share is the actual place to store certs in general on Linux. So you found the incantation. The incantation. Well, look at you. You did find it. Uh-huh. Subject DNS equals name. New X509 nodes days. Add text. Add extension. Subject. Shit. Key out. I mean, that's for the CA, yeah. Oh, okay. Yeah, that's not for a cert. The tough one is going to be the certs, because you're going to have all the domain names in there, and those are going to have to be detected from this host you're on. Do you have to be on the machine to make it? I'm guessing no. That would be silly. There's no like weird ties to the actual host to generate the cert, right? I mean, that would be weird. Unless you want to lock it to the hardware somehow, which would also be stupid. So, yeah. I feel like I can do this. I feel like I can do this now. What's an HSM? And HSM is a provider for all that stuff, right? Hardware security model. Decryption. Yeah. We were talking about HSMs. Is that who is it that mentioned one of the software HSMs out there that you can use if you want to? We're just doing Kubernetes. We're just learning about certificates and encryption. That's all we're doing. You can always fall back to kubeadm. I'm thinking about using kubeadm for this, actually. That's what root CA uses. Software hardware security module. What was the somebody mentioned one of the many providers for this kind of stuff out there. This is kind of assist you in your PKI deployment. Suggests that kubeadm can be configured with root CA. I haven't seen it anywhere. That's one of the reasons I'm curious. So by default, okay, so if we okay, this we know, all right? If you use, because I did the default. And we know this. We know that the default kubeadm does not make a root CA that signs both the etcd intermediate CA and the Kubernetes CA. So if you want the multi-tier architecture that we were drawing the other day or earlier, you can't do it. Not with the built-in. So that makes me wonder. It gives me pause. You can absolutely plug your custom PKI in. That's what we're doing. The consensus so far is pretty clearly in alignment here on the community that you really don't want, for a large installation or a decent installation, you really don't want to use the internal PKI, because that, you got private certs that are not being locked down, and they could potentially fall in the wrong hands and your cluster could get owned. And that there's pretty wide consensus on that point. Therefore, the default creation of certs, as we've just demonstrated, is that the kubeadm will make a root CA for Kubernetes, and it will make a root CA for etcd, and then it will create the certs under that using those issuers. But it does not use them as intermediary CAs, allowing all of them to be tied to a single CA, or single root CA. And so that is that is a problem. Yeah, we were just looking at this one. Actually, we were looking at a different variation of this one. Pretty sure. I think it's up higher that we were looking, though. Oh, no, this is a different one. PKI, certificates and requirements of Kubernetes. And that's what we were just reading about. Certificates directory. Okay, this little tidbit right here is not in the starting manual. I cannot overstate how annoying that is. I've already said it like 5 times. But so here's the generic getting started manual, right? That tells you to use kubeadm to do installation. There's not a single breathed word in any of this about certdir at all. There's not even a thing that says maybe you want to use an external PKI. And Tony Fa and others have said, well, that's an advanced topic. They're not going to tell that to beginners. I'm like, okay, but at least they could have said it's an advanced topic and linked it, but they didn't. So that left a bunch of people to tell me, hey, well, here you go. Here's the thing. And the piece of truth that came out of that really just blew my mind. Because I literally went through every single argument of the kubeadm thing to try to get a handle on what's going to happen. And when I came to the --cert-dir argument, I was like, this is interesting. Do I point this at user local CA certificates if I want to manage my own? Is it going to blow them away? Is it going to auto-generate on top of existing production CA certs that I might have? And here is the magic information. To do so, you must place your external certs in whatever directory is specified by the cert directory flag. By default, it is etc Kubernetes PKI. If a given certificate, so this is so critical. If a given certificate and private key pair exists before running a kubeadm init, that means if there's something there already, it will not be blown away. It will be used instead. QDM does not override them. This means that you can, for example, copy an existing CA into blah and a CA here, and kubeadm will use this CA for signing the rest of the certificates. Now, something I find interesting here is that you can just copy ca.crt and ca.key and be done with it. Now, I assume as soon as you do that, that you want to remove it because the whole point of it is to be secure, right? So another thing I have a question about is, am I going to have to copy those certs every time when I set up a control plane? Am I going to have to copy the ca.crt file? I have a feeling the answer is yes, into the etc Kubernetes, whatever PKI. And then am I going to, every single time, does that include the join commands? For how much of the time does the ca.cert file have to be there? Moving the key if you do it that way, right? You need ca.key for internal Kubernetes stuff all the time. See external CA mode. Okay. All right, let's keep reading. So it is possible to provide only the ca.cert file and not the ca.key file. This is only available to root CA file. That's exactly what we want. Not other cert pairs. This is only available for the root CA file, not other cert pairs. If all other certificates and kubeconfig files are in place, kubeadm recognizes this condition and activates the external CA mode, which we want. kubeadm will proceed without the CA key on disk. So all you really need is the ca.cert, which has the public key from the root. The key time is large. It's a major effort to keep up the docs. I know it is, and I want to help, but it still makes it difficult. I don't care. I know people are doing things. I'm not trying to be ungrateful. I just am annoyed. I know. And it's crazy complex, and it's changing all the time. Yeah. Tell me why, though, that they stopped the allowance of using the GitHub resources for the certification exam when they were allowing it last year, and they just stopped that. That is solely stupid, especially since they link directly to a GitHub file in the docs. We just noticed that yesterday. 2 days ago, we just noticed that the CKA and the CCAD dropped the use of the GitHub repos for Kubernetes from the ability on the exam. You can do it for the CKS, but you can't do it for the other two. They dropped it. I don't know, man. People were looking up the command, I guess, or something. Who knows? To me, that seems like a really sloppy way to deal with a problem in certification. I don't mind telling you I'm actively against certification at this point. But some people will do it. So it's also possible to provide only the ca.cert file and not the ca.key file. Okay, we did that. Instead, run the control manager standalone with controllers. What the hell? Controllers equals CRC signer and point to the CR certificates key. I have no idea. I don't know. They just did. It's kind of a surprise because we were looking at certs last year and we're like, what the hell? They took away some of our accepted resources to review. The reason because I wanted to just git clone the Kubernetes source and look through it and get good with knowing what was in there, and as a method of like owning the test. And then I found that you can't do that anymore. It kind of upset me. I was like, why? And why aren't you talking about the change somewhere to explain yourself? PKI certificates and requirements includes guidance on setting up a cluster to use an external CA. Well, during the exam, you probably don't have time, but I regularly go to the source code to try to get answers. And yeah. And testing if I have anything but Kubernetes IO equals a fail. Yeah. I imagine that's what happened. Yeah. Yeah. Well, I mean, yeah. Right. So they, whatever. That doesn't constitute, because they had implementation problems. I don't care. Sorry. That should not dictate the policy about what information you can access, because you can't figure out how to limit it because you don't know how to do it. It's part of the problem with the whole certification process and period. You have this antagonistic relationship between you and the people that are trying to certify you, and their goal is to make sure you don't cheat, which includes looking at the source code in this case, apparently. And it has no basis in reality whatsoever. And then I found out that they don't even talk about external CAs. They don't even mention stacked etcd configuration. It's all advanced. So I'm like, well, how do you... Basically, I'm really glad I went through that, because now I realize anybody with a CKA has no fucking idea what they're doing in an on-prem cluster at all, unless they have other proof of that. So next time I'm called in to be an SME, because I will be, they're gonna probably want my opinion and to vet potential client people, because we got to bring 2 more people on the team. And I guarantee you, if all you have is a CKA or a CKAD, I'm gonna look at it. I'm gonna say, what else you got to show me? Because this is not enough. And I know that now because I've gotten a lot of feedback from everybody as we've been going through it. They're like, none of this is on the test. I'm like, you got to be kidding me. Load balancing is not on the test. No, that's external to Kubernetes. It doesn't count. Okay. So whatever. So yeah, it's just one example. I've had so many of those examples over the last week that my confidence in the CKA is completely zero at this point. It isn't part of it. It doesn't matter. I want somebody who can do the job. Right now, the people who left us with a clusterfuck that has no load balancing whatsoever is doing round robin DNS because they don't even know it exists. I don't want to hire somebody back who's going to do the same exact thing. And I'm a total noob at this shit. And I figured that out by just reading the docs and setting up my own cluster, which none of these people are doing. Nobody. None of the potential on-prem Kubernetes administrators who are going for jobs are actually setting up clusters of their own and figuring this stuff out and learning Ingress and CNI and external CAs and stacked etcd and load balancers and the difference between HE proxy. None of them. Never set up their own cluster. No, and I was hired without setting up my own cluster as a Kubernetes admin. You can learn it. Because I had significant experience in IT, and that's true. But the mountain ahead of you to learn all the things necessary to run an on-prem Kubernetes cluster is so significant that I can tell you right now that if I ever get in a position where I'm hiring people like this, that I know what to look for, and it ain't a fucking CKA. unless we're looking to hire people that are going to do GCP or that kind of stuff, that have all that stuff already deployed, because all of those advanced things are actually not advanced. They're mandatory and critical to an on-prem cluster. All right, I got to calm down. Calm down, Rob. Calm down. Whew. All right, so I'm not angry. Joining the job, you just ask questions. Yeah, I didn't know any of it. The thing that sucks now, and I'm going to end on this negative note. I think we're done with CAs. I got to put this down for a while. I do. I got to put it down for a while because I'm getting into it, and I have to make a decision about whether to use openssl or kubeadm certs or blah blah blah. I mean, I have yet another decision to make, and I like that I do have to make all these things, and I'm not against it, but it is frustrating. It's frustrating because many of these things I didn't know when they hired me, and now I'm, if not the senior, one of the senior people left on the team is responsible to get us from 121 to 124, potentially 126 by January. Use a cert manager, call it a day. Well, that's what we're thinking about doing. I mean, but every one of these decisions, there's like 5 or 10 considerations about the decision. Those decisions, there are one best way to do things. There are, depending on your infrastructure. And I think that the flow chart of that, if you want to save the industry, you need to create a decision tree for people that are doing on-prem or not. Maybe have the decision tree include people who don't need on-prem. And say, look, do you need cloud or not? Okay, go to cloud. Do you need it? Do you need on-prem? Fine, here you go. And what's your budget? Do you have a huge budget? Do OpenShift? Do you not? Maybe try OpenStack. Do you want to build your own and you have a lot of time and energy but no money? Okay, maybe do this. There needs to be a decision tree to help people build out. People, they get paid for this kind of consultation, and there needs to be this because this is going to take down the on-prem deployments out there. All it's really doing is lining the pockets of people who create these turnkey solutions. Because like the clouds, it's just, and the reason there's no political will or financial will to do this is because no one's making money going through it the way we're doing it. The people that are making money to take care of all this stuff and have a turnkey thing it's already set up. Red Hat, OpenStack, GCP, whatever, GKE, whatever. It's easy mode. Yeah. Sure, Magic can be backed up on-prem by on-prem KMS, cloud KMS, HashiCorp Evolve. Yeah. PKI. Having your own PKI initiative is obviously not within the scope of Kubernetes, but it is within the scope of infrastructure management. And hiring somebody that doesn't understand that, I think is a DevOps person is bad. I mean, they need to eventually learn it. And they hired me without knowing it 2 years ago, and I still haven't got it. I've been kicking ass writing code that they couldn't even dream of creating. Nobody could even do any Go before I came out of the thing. And all this stuff, it's not like I'm not producing value for my employer, but the amount of learning and maintenance and work just required to maintain 3 clusters of Kubernetes is overwhelming. It's fucking overwhelming. And it has half of it, at least 30% of it, has nothing to do with Kubernetes. Load balancing, PKI, etcd management, system storage classes, potential ingress. These things have nothing to do technically with Kubernetes, but they're critical. You can't have a Kubernetes admin who doesn't understand how to interface with those things. Otherwise you get like a fucking ARP storm like we had the other day, a while back. Because people misconfigured their Kubernetes, and all of a sudden the Kubernetes cluster networking was like trouncing all over the ARP tables from some other like technical debt that had been deployed. It's cloudy with a chance of ARP, exactly. Certs on the CKA, etcd is on the CKA, only HA is not on the CKA. But certs with the kubeadm, right? Shut off the spanning tree. Just exactly. ARP Hurricane. Yeah. HA is not on the CK. HA got a large part of the point of Kubernetes. Yeah, you would think. I mean, and then the docs, the docs are all over the place. They're oh, you forgot to read this other thing that's not listed because it's over here, And I'm not angry. It's interesting. I mean, I'm a pretty, I'm a pretty technical guy, but the amount, the sheer avalanche of critical knowledge you have to manage a Kubernetes cluster properly on-prem is overwhelming. It's absolutely overwhelming. And then you can't even keep people because the people who have any clue about how to do this, true story. This is a true story. Both of the people who left, one of them set up the prod cluster, got it all going. The other person helped them set up the prod cluster, and then they set up an infrastructure cluster all by themselves. Within a week, they were gone to greener pastures to do other things. Because as soon as you, and this is a positive thing, as soon as you actually can prove that you can set up, install, and run an on-prem Kubernetes cluster with Elasticsearch, Prometheus, Grafana, basic things, Argo CD, Tecton, and run a few applications in the thing, as soon as you actually can prove you can do that, you can write your own fucking ticket anywhere. Because the amount of drought of people who actually know how to set up and maintain an on-prem cluster is real. It's very real. These people do not have the skill. And if you have the skill, it is break time. I know, I'm a little angry. I know the Telenia Files is. It's probably time for me to rate somebody. I've been streaming since 5 hours, so I'll stop ranting and start doing something that's not. I'll come back to this. I will. I'll come back tonight and do it. I'm going to take my break and go. I was just really hoping to get farther along than this, and not just because of the talking and stuff. I'm starting to get. What I'm tired of is all the options. That's what I'm tired of. The thing that's wearing on me is all the different options for everything. Everything is like, well, that depends. Well, that depends. Well, that depends on this. It's like, no, you need to make a one best kind of scenario and then go with it. Anyway, and learn how it works. And then you don't use it and move on. I'm going to do a CA. I'm going to do a root CA for sure. It's like setting up a JavaScript project these days. CNCF certified distribution and best of breed tools for turnkey Kubernetes. Yeah. What is that? Is that a thing? Is that a book? Oh, are you talking about Charmed? Yeah, I don't know about Charmed. I looked at that briefly the other day. I mean, the problem... There's a sweet spot between picking a bunch of best defaults for you and giving you choices. And I think the source of my angst is that I haven't seen the perfect balance between those two yet anywhere. And pure upstream production grade Kubernetes cluster. Yeah. This I mean, it looks interesting, but I just don't think I would ever composable Kubernetes. I mean, I think there's a lot of initiatives that are going in the right direction, and God knows it was worse than this when we were back in Hightower's day. When Kelsey Hightower, the hard way thing, that was like literally the only way for a long time before kubeadm even existed. If people forget, and Tony reminds us all the time, that there was a time when there was no such thing as kubeadm. You had to set up all of these independent daemons all by themselves, all independently, and the Kubernetes was just a specification for how to do something, and it still is to this day. But these days, you can pretty much lock down. Like, for example, etcd was not locked down officially, right? etcd was like, well, etcd is the way to do Kubernetes today. But there's somebody was just telling me they deployed client and Postgres instead of etcd the other day. It's like, no, Kubernetes doesn't say anything about that. You could be certified Kubernetes and not use it. And I don't know how I feel about that. In a world where you're used to dealing with concretes, the Kubernetes variations are, the flexibility is good on one hand, but it's also extremely paralyzing, and it makes it almost impossible to find people who can do it. Because just certificates, you could have somebody who is a certificates expert, and that could be their full-time job. Just that. Just PKI. Just running PKI in the company. That's it. So, don't need to manage on-prem Kate's CKA may be enough for GKE case. Absolutely. CKA and CCAD, I've come to believe, are specifically for cloud deployments. I don't think, I think I wish they would just come clean and say, the certs do not have anything to do with on-prem. Everything under the on-prem umbrella is advanced and needs its own cert and does not qualify. That's what I think that they should say very openly. Because, I mean, there's enough to learn just with the stuff to be able to make the cloud work. Right? Who immediately says yes to running on-prem Kubernetes is a suspect. Yeah, that's very true. We have a very solid reason for running on-prem Kubernetes. Yeah, we really do. People laugh all the time when they hear that we're running on-prem Kubernetes. I'm like, you do not know our company. The models that we run through batch through Kubernetes would make most clouds like scream bloody murder. We have our own A100s, V100s. I mean, we are doing shit that nobody is doing in Kubernetes. Probably shouldn't be doing in Kubernetes, most of it. Mainly is tricky. Your first encounter was on-prem in Nomad? Yeah. I think I could be convinced to use Nomad because you're just looking for running containers somewhere is really all you're trying to do. Yeah. I mean, the fact that Istio had to come in and like make up for all the missing things in Kubernetes and the whole lack of storage problem, I think honestly, I think Kubernetes has huge flaws at this point. And I think that it's got a lot of unnecessary over engineering, no doubt. The certs are not that though. The certs are of course essential. So I'm not going to put that down at all. 3-node cluster on DigitalOcean, it broke itself over time due to changes in how things are configured. It was impossible to run down. Why? Yeah, because observability and logging and all that stuff, all the administration, this is the second day program problem. It's a real thing. It doesn't change anything. You still have to use it. It's still going to be around. It's not going anywhere. So it was for observability. It was the first thing. What did you do? Did you do Prometheus or did you do the tracing stuff? Was it open trace, open stuff? Yeah. After on-prem with self-hosted hard mode in production, then kubeadm, and now we're paying someone else. Prometheus Grafana, that's all? Really? Yeah. They did for logs, but haven't got there. Yes. We need to do Prometheus Grafana and logging. Yeah. Yeah, the guy that left, we lost 3 people. Yeah, we lost 3 people, and one of the guys that left because he was sick. I feel bad for the guy if he was. I don't think he was though. He apparently had all of Prometheus set up ready to go, but it was on his personal machine. Okay. I've been around the block. I recognize bullshit when I hear it. It's like, oh, okay. Yeah. What's the storage reason for the cluster? GPFS over NFS? It's horrible. It's fucking horrible. No. Do you use Hoster for Prometheus? Do you use Hoster for Elasticsearch? That's a joke. I'm sure he's not using Hoster. I am absolutely sure he's not using Hoster. Let's ship his personal machine. Why would you set up work stuff on your personal machine? I think you need more experience. See this thing over here that I built? $30,000 it cost me? Do you know why it exists? Even though it's mostly because of old hardware that I reused, right? I could not do this job without this. And as much as my managers and all the rest of my team want to deny that that's true, none of them have ever installed Kubernetes ever. So let me tell you something. Your personal home lab in this world is an essential tool. And if you can't make one, do something else. Do something else because you are going to need it. I can't go test setting up my own PKI on so that I can give them advice. I can't set up load balancing using ARP redirects, using even the development cluster on our home network at work. So I don't put down the guy for saying that he has personal computer stuff where in his home lab he's got that stuff all set up. I'm not putting that down. It is true that you often need one. Your laptop has 64 gigs of RAM. VMs, I know VMs are the best. In fact, that's where I'm going with this, by the way, Tony. I don't know if you know that, right? So I did get that. I did get the 28 core, 128 gigabyte, 256 SSD VM server over here. I plan on using the VM server so I can, believe it or not, I know it's impossible to believe right now, but eventually I am going to bring up and rip down on-prem clusters like that. And I want to get so good at it that I'm going to do it like every other week or every month, like lifting weights. And I'm going to bring up and tear down different configurations of on-prem clusters using my VMs on demand. And I'm going to write Ansible rules for it. And I'm going to get just so good with bringing one up and bring it down. And then I'll have my main one to take care of that does all my other stuff. So let's say I want to bring up OpenShift, or I want to bring up a bunch of VMs that are running Rocky, and I need to set up bridging properly because we have a client that's insists on using Red Hat. I can do all of that with the VM, and I'll be able to pull that up and bring that down. And once I get Ansible and Terraform potentially locally, I'll be able to do that much more fast. And because the truth is, if you're going to do this job professionally at the higher level, my next level, then you need to be able to come into a shop and go, what you got? Show me what you got. And you're able to go down that decision tree in your head and give people the right direction. And I honestly feel like I can't do that right now. I wish I could. I'm getting closer, but I can tell them how to manage their CS. Do you already have a PKI? What's your PKI solution? What's your identity management? Are you thinking about zero trust, or you got a VPN going on already? Are you a Microsoft shop? Are you a Red Hat shop? Do you got a lot of money? Can you pay for OpenShift? I mean, there's so many like architectural level decisions that have to be made. And at my age, those are the kind of decisions I want to be able to make quickly and easily and safely. And the only way to actually get experience with that is to break shit. And hopefully you don't break shit on the engagement. You do it someplace else. And then you say, hey, let me tell you, once upon a time when I broke my personal lab by trying this combo that I'm about to tell you that you're actually using right now. What I'll do is build another box just like this and put Ceph on it. Yeah. So Ceph is a big question. I'll mark all by itself. I'm not ready to recommend Ceph yet because I don't have experience with it. But there are so many components to IT infrastructure that are related to cloud, but not necessarily dependent on cloud. And, we've talked about a lot of them. It's exciting. I love it. I love it. I'm a little bit, tired right now because I've been streaming for fucking 5 hours, 5 hours and 55 minutes. But I don't get the wrong impression. I do love it. I think it's a good career. It'll keep you challenged. But there are times when you just want it to be easy. And then that's when things, start to annoy you. And everybody else. And they certainly are as your customers. Try to tell any of these things to your CTO, your Terry Colby CTO, who just runs the purse strings, is wondering why it's taking so long to get Kubernetes installed. I'm going to have to tell... I'm not happy about what I'm going to have to report to my team on Monday or Tuesday when I say, A, we have no backups at all. B, we should have been doing load balancing differently. C, there's like so many things that I'm going to be telling them. I'm going to be like, why the hell didn't you tell me this before? And I'm going to be like, because I didn't know before, because I hadn't taken a close enough look, but including our infrastructure cluster you just set up is totally fucked up. And like, well, tell us how it's fucked up. And I say, well, this and this and this. And how do you know that? It's like, well, I've been working on my own cluster at home. And like, okay, well, what other experience do you have? It's your word against theirs. It's already working. So it's a thing, and so it's going to be challenging because I'm working with a team that doesn't have any basis. They have nothing to go on. They don't have anything to go on. They don't know anything about any of this stuff. So, and I'm a noob. So we really do need a Tawny Fa to come in and clean up the house here. And set it straight and make decisions, which is why it's one of the reasons I'm doing this online, because I have access to you amazing people. So you can say, why the hell aren't you even considering QVIP versus, HA proxy? You can have a debate and I can go back to my team and I can say, well, let me tell you how the debate's going out there in the industry. This is what people are talking about. They're like, oh, it's great to have you on the team. Nobody even knows anything about that. I didn't know about. They have no idea. I promise you, they've never heard of HA proxy and they've never ever heard of QVIP, ever. So this stuff is valuable. It's just a little bit annoying. It can smell more than others. Yes. A stateless way to go. We haven't even got to storage classes yet. And I really, one of the reasons I wanted to do this is to get to storage classes and etcd backups. And we're not even close to that. So, I mean, unless I start, shooting from the hip and putting a bunch of stuff out there that running kubeadm without any considerations for the PKI. So look, the cert stuff that we've done today is really important. I made a lot of progress. I'm going to stay positive. We came up with a lot of things. I feel like I understand how the certs are working. I know how to generate the certs. I'm a little unclear about whether I'm going to use openssl or I'm going to use kubeadm cert to generate the certs in my cluster, as well as potentially the upgraded servers that we're going to be using, because we're going to have to reissue new certs. That's a part of if you're going to do external management of your PKI of your certs, then you got to make sure that you reissue your certs safely and regularly. And I don't know. I have to go dig up the documentation for the thing that even reminds us to renew our certs. Our certs could expire tomorrow and I wouldn't know it, because I think we have an alert set up for that, but that's going to be something that I'm going to be really digging into. And now I can. So the positive part of this today, I'm trying to get positive here. The positive part of this today is I can go to work tomorrow and I can dig through the certificates in our current deployments in our 3 different clusters that we maintain, which is humble compared to most of you. Some of you have 15 clusters. And at that time, I can say, okay, this cert's about to expire. We're running a root CA. All of these things have their own CA, potentially incorrectly. I mean, I can go look at the certificates and I can immediately know what's up and know what's going on because of today, because of your help and because of, my like deep diving into all of these questions. And then the book, LBG, you and I have talked about this a lot. I don't want anybody's contribution here to feel lost. I am hell-bent on writing a administrator-driven or administrator-focused book that is full of infrastructure engineering decisions that are related to cloud native, and that help you to decide your scale and scope and make these important decisions so that somebody who doesn't have strong leadership in the space can feel confident making these decisions, because God knows I don't. And that's why, I have you. So yeah, the Ultimate Guide to On-Prem Kubernetes, that's what I think it should be. I don't know if I would use Ultimate, but yeah, like I would say like a decision-driven guide, a decision-driven guide to on-prem Kubernetes. In other words, okay, we're to this point now. Where do you want to go? Do you want to go here? Do you want to go there? And the first decision tree in the entire thing is, do you want on-prem or cloud? And that should be in the introduction. It says, look, 90% of you reading this right now have no business reading this. Go put the book back and use cloud. And I'm like, okay. But the rest of you, the way for on-prem Kubernetes, yeah. Yeah, don't followed by 400 empty pages for notes. One word, don't. Learn Kubernetes in 10 minutes. Use Charmed or MAS environmental. Yeah. The problem with writing that book is that there is, if you're going to do it honestly, you have to keep abreast of the turnkey offerings in the industry. So we would have to decide whether the existing turnkey offerings are in scope or not. And we would have to say, okay, you can't talk about on-prem Kubernetes without talking about OpenShift. Let's just be real. And frankly, right at this point, OpenShift looks pretty damn attractive to me, because if I were to put my IT architect manager hat on for a second, okay, and I had my team, and I had to make a choice. I had to say, look, I can pay 30 grand for OpenShift, or I can buy half of another person to run a vanilla Kubernetes, customized Kubernetes on-prem build. What would you use? If anything, these streams have been like advertising for OpenShift, because, or whatever the other one is, or Charmed, which is apparently free. So, or OpenStack, right? Because these things come with all the decisions made for you. By OpenShift, have a bunch of Red Hat people come over and they'll make you get time to work on more core business things. Yeah. And that's, look, if I'm making a business decision, and I have been a business leader, I was, ran my own business. If I had to make a decision and I had a certain number of dollars and I could allocate those dollars toward extremely overpriced, impossible to find Kubernetes administrators who were used to building on-prem Kubernetes clusters like I'm trying to be, or I could pay a Red Hat team, certified people of OpenShift, what are they going to do? The price tag on OpenShift now looks very, very attractive, because the marketing, at least, and I have no direct experience with it, the marketing on the OpenShift is that all of the best possible decisions. OpenShift's like Python, it's like one best way to do something. And the way I'm doing it is like the Perl way of doing Kubernetes. It's like there's a million different things for you to choose and manage on your own. And by the way, you have to be an expert in all of those things. And kubeadm comes pretty damn close to taking care of all that problem for you. But then then every once in a while they hit you with, but if you want to do it safely and at scale and have high availability, then you shouldn't use kubeadm for this. You should actually use this other route through kubeadm. And like, what the fuck? Yeah, pay me in out pocket at 30K and use Charm for free. We don't know if Charm works yet. Charm does not have a reputation in the industry at all. So, you know, if you're going to try to convince the person with the purse strings to tank their existing deployment and invest everything in something else, it's going to take some reputability and some established success. And you don't have that any place but OpenShift. OpenShift has got wild success under its belt. And that's why people pay the big bucks for it. Especially if for every second I'm down, I'm going to lose $3,000 a day to rent an A100. So I don't know. I mean, it's interesting though, because I mean, I still am going to do it this way. As I said, my fictional scenario is a small underfunded think tank with machine learning people. That is my imaginary scenario. And it's not, people were suggesting that it's so specific and it's probably not imaginary. I promise you it is. It's not. It's my real life scenario is a company with crazy ass money, with 20,000 employees, that, you know, tries all kinds of random shit because they can, because they're just so fucking rich. And that's the real scenario, but that's not the scenario I want to get good with supporting. So it really is imaginary, I'm telling you. It is. The imaginary scenario that I want the you know, the business case, the work, whatever, is that it's a small, you know, underpaid, you know, living off government money, machine learning group, and they're trying to do amazing things, and they don't have a lot of hardware. That's my target, and they can't use Red Hat. So what are their options? What are their options? Do they don't get to play in the Kubernetes space? Maybe they're better off using Nomad to run their jobs. You know, they might be, actually. You know, goddamn, I don't even want to admit that. Yeah. Oh my God, I don't even want to think about that. How is running a machine learning job any different than running a 3D rendering job, like the case study that's used for Nomad? There's videos on that. No, Nomad absolutely works with GPU workloads. It absolutely does. In fact, here, I'll show you. There's a case study for Nomad where they interview a 3D rendering shop, and all they do are GPU rendering. That's it. I don't think it's different at all. So now I'm really, yeah, I don't think they need Kubernetes. I think they probably need Nomad. The only thing you need Kubernetes for is complicated applications deployment or deploying applications that have already been written for it. And there are now many, many applications that, you know, that have lots of moving pieces that are deployed for Kubernetes. I actually think Nomad might be better for us internally. Yeah. It definitely would be better for our machine learning jobs. Yeah. What are you talking about? The size? Yeah. Yeah. For frequent canary deployments of code, yes. Size and scalability. For long-running containers. Nomad is for long-running containers, yes, for sure. Well, here's the thing. Most of the stuff that we have are long-running containers. I'm starting to realize this. The bulk of our work, the bulk of our machine learning work is our long-running jobs. They should be, and they're all GPU bound. I know. And Nomad has jobs akin to like they kind of like cross over to like the PBS kind of thing, like, you know, batch processing stuff. I'm like really seriously thinking about Nomad right now. Yeah. I mean, they have it, but the only reason people use Kubernetes just Docker is further away from config management, though. Ansible complexity. A 6-node Nomad cluster. I do too. We need to make room over here for a Nomad cluster for sure. I really need to understand what the limitations are of Nomad versus Kubernetes. Yeah. Large redundant infrastructure like Netflix. I know. That's not what this is, though. No, this is the company that I work for deployed Kubernetes because everybody was doing it. It was the thing to do. And now our infrastructure cluster is kind of tied to it because we deployed HashiCorp to it. HashiCorp's got a Kubernetes deployment. It has a standalone deployment, a Kubernetes deployment. It does not have a Nomad deployment. Blade Services said, yeah. Many more nodes and containers than Kate's. I believe it. Spinning up random stuff quickly. I don't know that. See, I would need to have some personal experience with Nomad versus Kubernetes for sure. But that's what I have a lab for. I'm sure I'd cool a bunch of blades in a 1-year rack quietly. It depends on what kind you get. If you get, I have commodity hardware that's nice and quiet. It's hot, but it's quiet. So it's not running GPU at max though. I haven't turned that on yet. Yeah, I think Nomad is definitely worth a look. I don't think people should count it out. HashiCorp are fucking brilliant. The engineers at HashiCorp are some of the best in the world. I've seen the internal software that they've written, like for things as simple as like plugin architecture over stud-in and stuff. It's just the engineers over there are really, really top notch. They really are. And the thing I like about the engineers at HashiCorp, yeah, me too. I do. If HashiCorp's out there, I would love to work there. Yeah. They're so, I mean, I would feel so flattered if they would even take me on. I mean, because they are so good. The thing I like about HashiCorp is that they have the level of engineering expertise clearly on hand, but they also have a commitment to simplicity and user interfaces. It's not completely apparent in HCL. I wasn't too pleased with HCL, but they really understand the needs of the enterprise. They're real sharp, and they're fucking brave. They're like, oh, hey, Kubernetes is winning the race, and we're like, okay, Nomad. Like, okay, yeah, have fun with that. I mean, Google is famous for over-engineering shit that has no basis in reality and then gets thrown out. And HashiCorp has been really, really focused from the very beginning. They have been really crazy focused on the right things. They make a lot of good architectural decisions, in my opinion. And then I just look through their source code every once in a while, and I'm like, oh my God, this is beautiful. I don't have that feeling when I look through Kubernetes source code. As I think Tony Foss said, it was written by a lot of Java coders, right? Yeah, it seems a little convoluted. As staff all over the world, I think lots of remote work, lots of expertise. So damn pricey. They are pricey. They know that they're like top of the top. Yeah, I don't think being the first is good. Yeah. I don't know. I mean, Kubernetes has evolved to do lots of other things, and I'm still just a novice in terms of like on-prem, but yeah. I mean, just the API implementation itself, all by itself, is such a mess. It's good, but it's a mess. It's like monstrously huge. Has anybody ever cracked it open? Go crack open someday. Go crack open the OpenA specification for the Kubernetes API, just for fun. And then go look at the code that's used to render that shit. It's a pretty big monster. I mean, it's like an operating system, and that's the level of complexity that it's approaching, a true full-blown operating system. And the reason I get frustrated is because it is not a stretch to say that to learn Kubernetes, you are learning an operating system at the low level. It's like learning how kernel internals work, and how injecting a module is going to be, how that code and memory is going to be connected to everything. I mean, it is not unlike that at all. How processes do inter-process communication and stuff. And how's it going, Fatma? Become an intern at HashiCorp. If you could, boy, being an intern at HashiCorp, that would be a golden ticket to anywhere you wanted to go, especially if you're interested in Go programming. HashiCorp's been coding in Go way before a lot of other people. Way, way, way before. So yeah. Yeah, I'm doing that thing where I'm just pondering right now. I don't know how interesting that is. I mean, this is usually the point at which I just leave and then I get some sleep and I wake up and I'm like, oh my God, what was I doing? We'll just go get the cert and we're good to go. I am not looking forward to a conversation I'm going to have with my team tomorrow at some point. Because here's the problem. We have I don't need to share that dirty laundry here. It's not really dirty laundry. I have a really core API that senior directors want written. And I've been writing most of the Go code on it recently, cleaning it up and reorganizing it and making it suitable for consumption and sustainability. I mean, it's going to be a core API forever. And so I've been doing all this Go programming on that. And at the same time, we have this, 3-stage, 3-version upgrade of Kubernetes coming within 2 months. Within 2 months, we have to be able to do all of this stuff without any problems. And I already wrote all the tooling for the Open API generator and everything, and that's taking priority. So I've got 1 foot in the software developer place that's got all the eyes of the directors on it, and on the other side, the very unsexy side, I have to be able to say, our Kubernetes stuff needs attention, or it's going to fall on its fucking face, and it's hard because we should really have another person or 3 to do this work right now. And so I'm kind of feeling it because I just happen to be able to do all the development. And, I'm only 1 of 2 people on the team can even do the development. So yeah, learn to code, my friends, learn to code and Go, by the way. Learn to code and go, learn to go. Hiring people from outside the US. I have no idea. I need to talk. My recruiter called me on Friday. That reminds me, I need to do my time card. But my recruiter called me on Friday. I think they want to talk about potential hires. They're probably looking for people. I know they're going to ask me. They're going to ask me the same thing they ask me every time. You got anybody for me? And I'm just going to ask you, are you ready to work for us? After seeing all the stuff that you've been seeing and scaring the shit out of you, are you ready to come work for us? Because I've got 2 open positions, and I have a recruiter who is hiring. I am not lying. So, do you want to buy a franchise? Copy and paste the chatter list. Yeah, nobody wants to be on this team now. Yeah. I learned to go via admin of code. Really? Yeah. Scary stuff first. Yeah. So this team that I'm on, I don't mind being here. What's the worst going to happen? They get rid of me and I go walk into another job doing whatever the fuck, including I could probably make another 50 grand if I switch back over to Go programming. If I switched over to internal Go, writing Go APIs and middleware, I could probably add another 50K to what I'm making now, which is not too bad actually. So I'm not worried if we fall down. It's just, it's experimental, but yeah, there's not a lot of people that want in this. In fact, the people that were here, one of the contractors is all of a sudden sick, doesn't want anything to do with it. And I'm like, what the hell? I might as well stay. It's like, what's the worst that can happen? The whole Kubernetes thing falls on its face and they fire me. Okay. So first of all, that's not going to happen. They're not that kind of people. They would be like, oh boy, let's figure it out. If I told you some of the shit that's gone down, you'd be like, how is that team still out there? What's that? Last night's AOC for some folks. I don't like advent code usually. Just my thing. It's a waste of time to me. I would rather code like my challenges are kind of advent code. They're really irrelevant projects, right? But yeah, complexity is hit and miss. Generally harder on the weekends. Yes. Am I on LinkedIn? No, I despise LinkedIn. So for lots of reasons I don't want to get into. Primarily the just entire company. It's just so bad. I don't want to talk about it. If you're on LinkedIn, you're a product more than you are on Facebook in a big way, especially if you post your company there. Do you realize that I took all of my stuff down, including all my company information, and they are still selling my corporate information to people? I get 20 to 50 emails a day from people trying to shill shit to me because they think I'm still running the corporation that's no longer even listed on GitHub, on LinkedIn. But they still feel it's their right to give away my information to everybody. I cannot overstate how much I think you should get the fuck off LinkedIn. You should, I mean, GitHub is still Microsoft, but in the tech world, being on GitHub is more valuable than LinkedIn, in my opinion. A lot of people say that's not true for them and that they got a great job, and I've never had a positive encounter on LinkedIn at all. The only good thing about LinkedIn was being able to stay connected with some of the people that taught me Linux from the early days, because I thought that was the only place to stay in connection with your business affiliates and associates. Guess what? You can do that without being on LinkedIn. It just takes more time. Yeah. It means to. It's just a means to an end. Yeah. Yeah, and there's a lot of people who have it. The thing, that real straw that broke the camel's back for me was when I went to go see if they had an API for me to get my data out of there so I could make a CV out of the data that I kept meticulously updated in LinkedIn. No such thing. Oh, I'm sorry. Yes, there is such a thing. There's an exhaustive API with a full data schema and everything, but you can't use it. The only people that can use it are their partners who have paid them lots of money. So you diligently use their web interface to put all this shit into their system, and the only way you can get it out is web scraping, and if you do that, they come after you legally. And they made it so you can't do that. They have the API. They have a complete API that you can like pull down all of your stuff and massage it into a resume template and everything like that. But you can't use it because you're just a user. You have to pay some god-awful subscription rate to do it. And as soon as that happened, that was the straw that broke the camel's back with me. I was like, they don't even give a shit about allowing me to use my data that I put in there. They're like, oh, sure, you can have your data. You just have to copy and paste it off this GUI interface that you put it on, even though we have a full REST API that we're letting a bunch of people use who are harvesting all of your data, but we're not letting you have your own data through the same API. What the fuck? LinkedIn. All right, time for me to go. Bye, YouTube.